Alrighty, stream 35. I'm just waiting for the little indicator. Up there it goes that we are live. Hello. Up to 437 unit tests in this project. That's a lot of unit tests. Look at all that. It's lovely, and it runs in 0.558 seconds. In the virtual machine, no less. Hey, I had a thought between streams. Remember how I did those literal booleans? I think I thought of a better way. So there was no logos construction that really fit right for literal booleans. So I hijacked regex. I think it would be better if we just define them the way we define the other reserved words, and then assign meaning to them in the parser. So that's what I think I would like to do right now, just to start things off. So I'm just going to turn them into tokens. Or is it... Yeah, it's just token with a string attached. Yeah. Right here. So that they really don't have a value, intrinsic value. They just become tokens, right? So we change regex to token. Hold on, let me just try to get the key combination correct. There we go. Multi-cursor is pretty sweet, I must say. So yeah, here we go. We have tokens for true and false. Right, so we have to chase all the errors down, right? So output Boolean becomes output true and false, right? Okay, but we have no token true and false. I kind of want to put these where the others were. So they were after the reserved words, right? But before, like, identifier. Is it after local? Yes, after local. We have true and we have false, and then we have the identifiers. Okay. So let's go where local is defined, and then we're going to just add true and false. So the reserved words, just like the other reserved words. So then the next step would be to go to the grammar. Okay. And then we remove the token Boolean and replace it with true. And that's token true. And we're going to have false again. And these are all ordered alphabetically. So let's put false where it belongs and true where it belongs. There. Okay, and then where I have Boolean again. So this becomes just true, right? And that's expression literal Boolean true. And false is literal Boolean false. I think that's all I need to do. Unless some of our unit tests might have like checked some of those interfaces. Building, 130 out of 136. Oh, 134 out of 136. Yep, broke some tests. Okay, so let's look for those. The Boolean test. Lexer tests. Okay. Lexer tests are all in one spot, right? So That would be, it's out, is it not output, it's lib, right? Yeah, okay. In here somewhere. Tests. Boolean, here we go. Right, so these, that's interesting. Did I forget to remove token Boolean? Yeah, I forgot to remove that. That's why the test failed. It should have caused a syntax error. Right, and this should just turn into true, and this should turn into false. Okay, that was it. Okay, some more broken things. In expression level 0, right? Yeah, okay, this is the grammar. The token changes from token Boolean, which doesn't exist anymore, to token true and token false. Cargo Clippy is struggling. Cargo Clippy. Cargo Clippy. Come on, go, 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 go. There it goes. Now we get to run our tests. Parse, parse, parse our test. Parse our test. Run, 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 run. Okay. We failed those tests. Those are different tests. Empty and invalid token. Oh, those two. Yeah. Okay. That's because we have two tests that are sensitive to looking at the expected next token, which these are listed here. So that this became false and true, right? Alphabetically sorted. So those are all valid tokens that can be the first token of an expression. And we have two tests that are sensitive to that. The empty and the invalid token. Hey, look at that. We passed all our tests. Okay, cool. So now I feel better because I didn't have to use the regex for true and false. We just made them reserved words, and we let the parser assign meaning to them right here. Didn't have to change anything else other than some tests. Okay, cool. So let's move back on to looking at the to-dos. So I think it's just set membership, vector, and map. So since we have sets, we can do set membership now, right? So let's do set membership. So ingestion, source, tests, we have set, right? All the set tests. Close others. Okay, so let's write a test. So this is set membership. Or set membership true, and we'll have a false one. So this would be like 69 is in 6942 set. The answer would be true. Okay. And then let's have a set membership false. Okay, there it's like, let's put 420. 420 is not in that set, so that's false. And then I want another test where I was gonna say where we get an error from the end, but I don't think. Oh yes, we would if we made this not a set anymore. So there, it should actually be an error. So let's assert foo.error. Membership not a set. So the right-hand side has to be a set, and I expect a certain diagnostic here. Although right now we're going to hit not implemented. So let's go implement that first. That's where the in operator is just not implemented. So left-hand side, in, right-hand side. And in is a reserved word, so I'm going to go ahead and use that special token, r hash, which lets us Actually, as the diagnostic would say here, if we really wanted to call it in, we could put, oh, I have to save first. If we really wanted to call it in, we would put our hash in front. Escape in to use it as an identifier. Although maybe I'd need to turn this around and say right-hand side dot left-hand side. Let's see if this works. And do I really want to force that in? I kind of do just because Rust lets me do that. So the idea would be we would make another module called in, and let's copy it from like one of the other set things. Like inclusive or has a set thing in there. Well, it doesn't really matter, but we'll do it anyway. In.rs and value would have a mod in. Again, we gotta escape it like that. And then we have a in our hash in. Okay, so we want to make sure the value on the right is a set. Otherwise, it's an error. So let's say let some value set right hand side equals value, else return error blank is not a set. Well, in operator requires right hand side to be a set. Just keep it simple. Okay, and semicolon there. So then the left-hand side can be any value, and we just want to see if it's in the set. So that means we're always going to return okay, and it's going to be some value Boolean, and the value in the Boolean is going to be, if we say right-hand side dot contains self. I think that's all I need. As long as this works. Expected an option. Oh, the left-hand side is never an option. So maybe I do want to flip this around and do right-hand side in left-hand side, because this says you can't do something on a nil value, but for in it's backwards. Hey there, Nightshade dude. We want to say like is nil in a set, right? If we try it now, it'll say cannot in something to a nil value, which is like not even like the correct actually no, we have a word for that, right? Cannot check for set, it'll say cannot check for set membership something to a nil value, which is going to be an odd way to say it, but that's what our verb is. Check for set membership. Yeah, the thing is, it's always left-hand side no matter what the operator is. So what I really want to do is swap the left and right-hand side. Or I guess we can go back to where this is called. Match on the op first, and if it's in, then swap left and right-hand side. Or I could just do it inside here, I guess. Which way is easier? Can we swap? Can I say like if op equals binary operator in, can we say like left-hand side swap? How do you swap two values in Rust? There's a way to do that, right? Rust swap two variables. How to swap two variables? Oh, you just use tuple context. Okay, so it would be something like this. Let LHS RHS equal, and then RHS LHS, else LHS RHS. This has to be flipped around, right? And that has to... Actually, that was the real problem. So why don't I just... That reads better to me if it's like that. Okay, then it's actually the other way around, right? For membership. So that's... actually, it's already flipped. So now I just have to think of it backwards. So LHS is the thing to test if it's... No, LHS is the set, and RHS is the thing that might be in the set. So this then would be... I don't actually need this. It's just if LHS contains... If self contains... No. I do need this thing. It's just that there's no sum, right? Let value set LHS equals self. And then, actually, I guess it's R, because value is now L. So that's RHS contains value. There we go. So I didn't need these at all. And we pass our test first try? Yes. And let me make sure that the diagnostic we get for this makes sense. In operator requires right-hand side to be a set. Cool. Awesome. All right, all right. What was super handy? I missed it. Something I did. Maybe it was multi-cursor. I think we've now cleared the way, so all we have left are map and vector. I wanted to do map first because map is really just an extension of set. Swapping using tuples? Oh, yeah. That was here. What's cool is it works with any type, even references. Super cool. Should write a comment here why I had to do this. Swap operands for set inclusion because it's natural to say member in set. It's natural to say member in set, and we want member. We want to allow member to be nil. Whereas we don't normally allow the left-hand side, left-hand operand to be nil because we usually type cast the right-hand operand to the left and operand type. Very long-winded explanation. Swap operands for set inclusion because it's natural to say member in set, and we want to allow member to be nil. Period. Next sentence. we don't normally allow the left-hand operand to be nil because we usually typecast the right-hand operand to the left-hand operand type. There we go. And there's the check right there. So evaluate. Well, evaluate is already there. So really this is compute. Really, we are computing. Compute the two values, to the two operands. Compute the two operands. Require the left-hand operand to be non-nil. And this is perform the operation based on the operator. Or select and perform the operation based on the operator. Exactly. I felt like that should have comments because we're doing different things and they kind of bled into each other. And this way it just kind of looks nicer, but strictly not required because I could read that code. I would, except for maybe this, and I maybe months from now I'd come back and say, why is in special, right? But that's obvious. This is obvious because the diagnostic says what we're looking for, and this is obvious. But once I made a comment here, I'm like, well, that comment doesn't apply to all of the code. So I want to put a line break here, and the line break here means I really want a comment to say, okay, now that we've done that, this is we're doing something different, and then I wanted to continue the trend. And I didn't want to be have a lame comment like do the rest of the function. So if I really wanted to get rid of the comments, what I'd do is I'd put this into a function and put these comments into the function. And then I just have one line function call for that, and then the rest of the code, and then I wouldn't need comments. But I'm okay with the comments. Which maybe is why my functions are too long. Maybe this should be, maybe that should be a function like swap operands for set membership or something like that. I don't know. Map. So there are two things about map, three things about map. One thing is that this is the map expression, which is how we do map constructions, like the constructor for a map. Second thing is we need to add a value type for map because there doesn't exist. Third thing is once we add the value type, we have to extend all the places where value is used to include maps. So that includes display trait, typecasting, and operators. So the same thing that we did for set. So we're going to end up like making a test probably just as long as set for map. So why don't we just start off by copying set to map. And we'll just replace all test sets with test map. Okay. And then where's tests? Here it is. We're going to have mod map. Okay. Close all others except for this one. So a map. So a map is brace. And then the end brace is that. And then instead of that construction, it's like that, I think. I need to look at my own grammar though. How do we construct a map? I don't see it. Oh, there it was. Key values. Key values. Key value. Key colon value with commas between them. And this is another instance where the way I wrote the grammar, you can actually start with a comma and you can't have a trailing comma. I kind of want it to be the other way around. The first key value shouldn't have a comma before it, and the last one can have one. You can have an extra one at the end. But yeah. Anyway, so that there is a trivial map. So the way this would work is we'd have a map, and then I think we're gonna extend this so it's gonna be tree map, B tree map instead of B tree set, and then let's search. Well, hold on. I was gonna say search replace and replace all that with that, but then I don't know how to search replace all of those. Actually, maybe that's not such a big deal. Maybe this isn't such a big deal. As long as we hit all of them. See, yeah, I just need to search replace all of these. Just say B tree map. And then we have to look up, I have to look up the syntax what B tree map looks like. So that's in maplet. Map literals. API reference, B tree map. Okay, so it's equals greater than instead of the commas. So I probably use that everywhere. So that should hit a lot of them, right? Okay, except for some of these, right? Yeah, so I think we'll hit those individually. Let's add data value map first. Here. B tree map. Option value to option value, right? Because none is nil, and we should allow nil to be both a key and a value. Okay, so that needs to be imported. Okay, and these errors are going to be like, we need to implement the try from, the display trait, the rank, all that good stuff. But I kind of want to fix the test first. So that test is just constructing one. I'm cool. Actually, I'm not so cool with that. Let's make another one like nil maps to foo and bar maps to nil so that we get some more interesting things here. So this would be none maps to string, foo to string. And then we have some, actually, I'm just going to copy that. Thank you. Some bar string maps to none. And is it commas between them? Yeah. Yeah, the formatter is scared to reformat inside of this macro, so I'll do it myself. So I'm just going to indent the values. Okay, so then that's one test, like a more exhaustive tree map, I mean. So here's where it's not empty. Map not empty. And then map empty. There, works. Map add non-map, right? Actually, does it make sense to have add? Because that works for a set because you don't need a value, but a non-map, I think I would need a tuple type. So maybe I just don't define that at all. Don't define it at all. Same thing here, right? We could define union, but not add or, yeah, not add. So how does union gonna work? What if they have colliding keys? Does the right-hand value take over the left-hand value, I guess? Yeah, I guess so. So I should probably have a test for that. So let's have I don't know, foo was 0 and now it's a 1. So that's 1 is 42 maps to 69. And then we have 69 mapping to 420. And then I need a string foo to string, and that maps to an integer 1. Comma, oh, no comma. Something else is wrong here. I'm like missing a punctuation somewhere, I think. No, okay, what's the deal then? Mismatched types. Oh, it's should be map, not set. So that probably isn't a lot of places. So let's fix that. There we go. Fixed it. Okay, intersection. So this should be something like I was gonna say like it's the map that has common keys, right? But then what values would they have? Would we use the left hand or the right hand or neither or what? What if we just select the keys that are in common? So if we have 42 maps to 69 and then like 42 maps to 420 and 69 maps to foo, the intersection should be just a set containing 42. Let's put an unrelated key here. 420 to 42. So it should be the keys that we selected. It should just be the key 42. So this one will be set, actually. B tree set 42. Okay, map subtract non-member. Oh, I hear a Ramu dog who wants to come in. I'll be right back. I'm gonna let the dog in. Oh, that was a puppy who wanted inside. Puppy wanted in. All right. Test map intersection. Hey, sir. Started Rust, as you told me last week. It's pretty amazing. Missing a semicolon is expression, adding a semicolon is statement. Yeah. Yeah, that's subtlety, right? If I were to do, and sometimes it doesn't matter if the expression has a unit type. It's as long as it's the last statement, you can have a semicolon or not. See, it works that way and it works that way. Yeah, there's a lot of subtlety in Rust. And that's probably the biggest one. The other one is the question mark operator. This is super subtle, this question mark operator. It's bound to the try trait, and what it does is it does two things. It converts the left-hand side to the if it's convertible, converts it to the correct error type or option type, and then it does a return if it's error or none. So I have one concern of adding types with values. What's your concern about adding types with values? That's similar to how what you'd use a union for in C, right? So this stuff, this is kind of like, if you're familiar with C, this would be a union where alongside the union you would have a discriminator, what they call it, saying like which member of the union is valid. Type coercion. Type coercion is not automatic in Rust, so it's not something to really be concerned of unless you mean you're concerned about how much work it would be. And yeah, I had to do that. So I have to do type coercion, quite a bit of it. That's all this stuff, right? So if I'm coercing to bool, that's what a try from is, right? In Rust, I had to handle all the cases of what it might be. Talking about 10I32 type thing. Well, that's just annotating the type of the thing. Practicing on practice.rs. I never used that one. Yeah, in Rust, when you do let x equal 10, unless you actually use it later, it'll sometimes default to I32, but it'll also sometimes say that it's of some unknown integer type. Usually if it needs to know the type and it doesn't know, it'll say like just integer and curly braces. But yeah, you can do a U32 and now the type is U32. Or you might do an I64 and now the type is I64. I see that as just another way of saying like a type annotation, because you can also just put it on the left. Now it's an I64 explicitly, right? So that is just another way of saying that. It's just a different syntax. But I think it's so too. I don't like using the type annotation on the right because I just think that looks nicer. One place where you would have to do that though is if you don't have a name for the thing. So if like you're calling a function, like some kind of foo, and it needs, this is sort of what's the word? I forget the word. The word's not coming to my mind. This is not a realistic case because in realistic cases, when you have a function, the function knows what type it'll accept. And so if you pass in an ambiguous value and it's expecting an I64, then it's the same as doing that. But contrived, that's the word. This is sort of a contrived example. But here's an example of one like place where let's say foo is something you can call and for however it's built, like maybe it's a trait. It's a function on an object that implements a trait that it could either accept an I32 or I64 somehow. Like you did some trait magic to do that. Then you might have to do that to disambiguate it. The only other way would be to do something like this, which you could do it that way. But then I kind of prefer that way because doing it this way with the turbofish, I think it's harder for me to read it because it's like it's attaching the type to the thing you're calling, not the thing you're passing in, right? Yeah, that stuff all is all weird when you're first learning it, but it kind of becomes second nature after a while. Well, I'm glad you're liking the Rust though. All right, I am adding maps, right? So we defined it there. And then I'm eventually gonna have to fix this up, but I'd rather fix the tests first, right? So I was doing map intersection and map union. So map union is going to replace values. Map intersection is going to return the set of keys that intersect. Because I can define it however I want. Yeah, I think I want map subtraction to be allowed. And it removes the key. So if I have 42 and I have like 43 is 70, if I subtract 420, I should not change anything, right? So I still have 42 goes to 69 and 43 goes to 70. But if I subtract a member, so that's like 42, 43 is 70. If I subtract 42, then I should have a map with just this second one in it. I think that's what I want. Okay, equals. I just have to fix that, right? Oh, there's two kinds of equal. There's equality on the key and equality on equal false keys, false key and this false value, where it's the same key but a different value. And then we have the true. The true has to match, right? But we have where it's returning. Oh, wait. This one I had purposely flipped it around. So I should also allow that to happen if I do like a comma. 43 is a 70. We should allow 43, 70, 42, 69. So they're listed in different order, but it should still be true. Okay, not equal false. So that's just the equals things reversed, right? So let me redo those. It's really copying the equals cases and flipping them around. Copy, paste. Oh, what's this error up here? I need a comma. Fixed. Okay. So this is not equal. False key. Not equal will be true. Not equal false value would be they're not equal and the value is different, so that's also true. And then not equal is true. So that is false. So really I reversed the truth here, so that's false. False key, false value. Oh no, that's true. Well, actually, we say that that's false and these are true. It's true that they're not equal. True key, true value, not equal false. Okay, so this is test map membership true. Yeah, so this is fine. It just has to be written like that. Right, so the same thing. Map membership, not a map. So there are actually a couple. Well, no, that's not true. This is sort of redundant because there's a set one. So let me just delete this one and we'll go back to set. And we'll say for that last test, set membership. Well, set membership not. We'll just say test membership, not a set or map. Okay. All right. So we have all our tests. No errors there. So we have to chase down all these values now, or all of these errors. For what kind of slip is that where you're going to say one word and your eye is looking at a different word and then that word transposes what you're about to say? That thing, that's what's happening to me. Okay, so this is try from, right? So it's the same kind of error. Maps cannot be cast to use size. All right, next error. So this is a try from bool. I think it's the same thing, right? It's if the keys are empty. Values. It's technically not values because a map has both keys and values. So really it should be map. All right, display. So set was pretty elaborate. Map is going to be also pretty elaborate, right? So map. So this is keys and values, right? Key value in map. So if it's not first, comma, space first, and then, yeah, we're going to have two of these and then a colon between them, right? So this will be the key, if it's some key, and then the value. And then we want to use curly braces for these markers. Okay, next. Rank. I guess map is 6. Actually, alphabetically, it should go there, so that should be, that bumps everything forward. These are arbitrary, so I don't really care, as long as they're in some kind of order. All right, cast to unsigned integer. There's no code action available, but the diagnostic is we're missing some maps, so we have to type that manually. Some map cannot convert map to unsigned integer. Moving on. Same thing with signed, right? Can't convert a map to a signed integer. Then we have cast to decimal. Can't convert map to decimal. Then we have describe type. Map. Okay, no more errors in this file, and we have all of the operators now have to be filled in. So add, we were going to have that, it doesn't make sense, right? So we're going to have adding maps is undefined. Next. Dividing maps is undefined, right? Next. Equality. We can do this one. So this is map. It's just we compare them directly. If we can't compare a map with a blank. Next error. Greater than or equal to. Order of maps is undefined, right? So this is going to be copied everywhere. So let's copy that whole line, go to the next, and just paste it here. Oh, I have to move it to the other side there. Okay. And then, again, order of maps is undefined. Modulo. Copy, paste. Dividing maps is undefined. Multiply. Multiplying maps is undefined. Not equal to. Okay, this one is like equal to, right? So copy, paste. So it's just a not equal to operator. Subtract. So this one we do define, just like set, right? So we have a submap and we remove the value. Cool. Hey, no more compiler errors. Probably broke some tests though. All right, so the map tests failed, the empty and all the equality ones failed. We have something not yet implemented. Map construction is not yet implemented. So this is what, two kinds of expressions? Oh, it's a vector of key values. Key values. So it's self.construct map. Construct map. I just noticed I have construct instead of construct. So let's see, how many times did I make that spelling mistake? Construct. Only twice. So that we can just do a refactor to fix the name. Construct. Okay, cool. So then let's make a construct map. So it's going to be the same as pretty close to what construct set does, right? Construct map instead. And then we have key values. Key value, right? Oh, is it? Do I have the V? The V is capitalized. Doesn't quite match, does it? Okay, anyway, we're going to make a map out of this, right? And we're going to be iterating the keys and values, and we're mapping key. Well, it's key value, right? And we'll tell it to fill in the fields. Key value, key and value maps to self. Okay, this is a little bit more elaborate. We have to evaluate both the key and the value. Either one, both of them are fallible. So it should be like self evaluate key expression and then with that value, with that key, evaluate the value, right? And then put the key on the left-hand side. And then put a question mark there. Oh, no, we already have a question mark there. Right, that's a non-result and that's a result. So I have to map it, right? I have to map the error then. I had to do it internally, actually. Actually, I got to do this in 2 steps now that I think about it. So it's value. It's evaluate the value and then if it's true, map it to key value. Like that. There we go. A little bit more complicated. And this syntax is a little funny. So what we can do is I can just say key value. And then I can say let that equal key value. And then it should read a little bit better. So take the key values, iterate them, map each one to destructure it so that we can evaluate the key, and then take the key, evaluate the value, map the value to the key and the value. So there are 2 ways we could get an error. The key can't evaluate, so it doesn't go into the end then, it just returns an error. We could get a good key, but then a bad value, and then it does not go into the map, and so we get the error back out. Third possibility is both of them are valid, so it constructs a tuple at the end with the key and the value. The key had to be forwarded to from the outer to the inner map, right? This being a sort of a map. And then, yeah, the way the collect works with the question mark is it's a result of either a map. Actually, if I do this, oh, it doesn't show it. It's either a map or an error, and this will turn it into result. Right, because it's inside of the constructor for map. If it's an error, it'll return an error immediately. Otherwise, it will unwrap the result and just give us the map, which the B tree map. I think my cat is dreaming. Yo, 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 Adjective Allison, how are you doing? I miss what Ada said. Turbofish is more work in that case, and passing the type seems more accurate in the case. Yeah, we were talking about the difference between foo 16u64 versus foo u64, a hypothetical function that is generic and whose type depends on its argument, right? You could write it like that, saying we're using the concrete type where the type parameter is unsigned in 64, and then that just gets cast to it implicitly, or we could be explicit in the value, and then from that context, it knows the type. And it's a contrived example, but I was saying that I prefer that because it's tied to the type is tied to the value. I've been in the super in the zone. Yeah, we're almost done with all the to-dos. So after this map, then we just have vector, and then essentially we'll be done, but vector is kind of complicated because implied by adding the vector type is we'll want to be able to build them from loop contexts. So technically we don't have any to-dos in the code, but I'll make new tests which will require code to be added. Okay, we have a map construction, so this should pass some of our tests, right? No, we're still failing. Did I not implement it correctly? Where's the map one? Test map failed. I don't see it though. Uh-oh. My Roomba just failed after it just started. Hold on, I'll be right back. I guess error 14 for Roomba is that the dust collector bin is loose. So I just unplugged it and plugged it back in again. Okay, so we got unreachable on comparison. Aha. That is true because we have a catch-all rule. So I need to add that here for map, right? Map. Cool. The magic of Rust, we just use the fact that we are implementing, well, the B-tree map implements ordering so that we can implement ordering based first on rank, and then after the same type, then we compare the maps directly. Okay, so test map passed. Now we have intersection and membership. The membership's new, right? Let me do the intersection. That's probably a simple mistake. Test map intersection. So we got a none, which suggests that there's an error. So let's look at the, okay, there's a logger. What's the standard error? Masking is unsupported for map. Oh, right. Intersection. Oh, right. I wanted that to be special. It ordinarily wouldn't be, right? So let's go to masking. Oh, no, it's not that it's unsupported. It's just I had to catch all. Okay, cool. So we're just missing the code. See, that's why we have tests, to make sure we have, we don't forget to write the code. Okay, so map, then we if we can cast, if the right hand side is also a map, then it's okay. We just have to do an intersection. And there's no intersection, but what we do is we do left hand side keys intersection with right hand side keys. And the result is a set, not a map. Cannot do intersection on the keys of a B-tree map. Why not? You can't intersect the keys? They don't support intersection? Oh, it's an iterator. Okay, so I'd have to like collect it first. And I have to say what we're collecting it in. So we're collecting it in a hash set. No, a B-tree set. Okay, and do I have to collect the right-hand side keys too? Probably because this takes another B-tree set. Okay, so then we got to do another collect in here. It still doesn't like it because we need to borrow that B-tree set. Okay, and then I guess I don't need to clone it, right? Because the collect will cause it to be cloned. The final collect doesn't like though. Ooh, it's a double borrow of an optional data. So what's the type? Iterator or an option. Oh, okay. Here it's cop two owned, right? And then collect it. Yes, and then in here two owned. Actually, I guess we might not need to own to own the right hand side, right? Because we're borrowing anyway, so I think I just need to take the references and collect them. But still the type is wrong. It still thinks they're references. Why? Is that because like intersection borrows, it doesn't convert it? Yeah, it's borrowing. Okay, that explains it. So then a clone doesn't really do anything, right? I want to actually dereference them, not clone them. But I can't because, yeah. I don't want to actually own them, do I then? Hold on. If I do that, then it's a B-tree set of options, yes. And then yeah, I want to like dereference them. So let's just map key to dereference, or is there a shorter way to do that? Why doesn't it let me dereference it? Cannot move out because it's shared. Move occurs because key has type. Okay, is it? So it is cloned. Do I have to clone twice? That's weird. Why did I have to clone twice? I don't know why I'm having to clone it twice, but I think it has to do with the fact that this keys is iterating the original map the original map's keys, and then we're making basically a set of references, and then the intersection makes another iterator wrapper, which is iterating references, so it's double referenced. So we have to clone twice to like dereference it completely. And maybe this one doesn't need to be cloned, it could just be a dereference. Yes, and then there's a shortcut, I guess. You're using explicit closure for copying elements, so it should just be copied. There we go. So we can copy the inner references, but to collect it into a new set, we do have to clone the keys because we're just borrowing from both sets. Or we're borrowing from the original set, right? So this actually makes our own copy, our own memory allocation, and the copy is copying the reference out. Double clone. Yeah, we don't want to double clone. I don't need to clone a reference. I can only, so this copies the reference and this clones the actual key. Copied, cloned, collect. The 3 C's. There's probably a better way to do this. So this is your opportunity, viewers and chatters and lurkers. If you can improve upon this, shout it out in chat and you get a point if it's better than, if I think it's better than what I have already. So you don't even need to know anything about my code. All you need to know is that it's 2 B-tree maps. And I want to form the B-tree set, which is the intersection of their keys. So I'm taking the keys from the left-hand side map, collecting them into a B-tree set, which maybe I don't need to do, but anyway, we're intersecting those the members of the B-tree set with what we get from the right-hand side's keys if we also collect that into a B-tree set. And then we're copying, because it's an iterator of references, we're copying the reference out, and then we're using the reference to make our own clone, like memory copy of the original key, and then we're collecting that into another set, which goes into here. I'm wondering if I could get rid of these inner sets. That would be nice, right? Maybe we don't need to collect into the set to. The problem is intersection is a member of the set, B-tree set, right? We're in the implementation of B-tree set, right? Keys is not a B-tree set, it is an iterator. So if I want to get a B-tree set from a keys iterator, I need to collect the keys into a B-tree set. But maybe there's a method of keys iterator that wouldn't it just be filter actually? Like to have no idea whatsoever. Okay, I think I might have an idea. So let's copy, paste, so we have the original around. Hold on, I got to do this properly. Copy, paste. Okay, there's the original. I think what we do, instead of collecting, we just filter. And we filter the key to be if the right-hand side contains that key. And then we should be able to directly clone and collect. Yeah, I think that gives us the same answer. So here it's iterating the keys of the first map and then applying a filter so that we discard any that aren't also in the right-hand side. And then clone gives us our own copy of the value inside the key, and then we collect it into a B-tree set. I think that is better. We probably can't get better than that unless B-tree map has something that does this directly, right? Like, give me a set from a map by cloning the keys. So then I don't need that. Go to the test again. Okay, so we just have the membership test, right? Unless, see, we're not running all of them, so it's bombing on the membership test. Let's go see there. Oh, I remember this. Yeah, so the in operator only works for sets right now. We need to extend it to work for maps. in.rs, right? It's expecting a set. So what I'm going to do is going to do a match self. And we're only going to accept map and set. Anything else is going to return the error. But we're going to change the error a little bit. In operator returns right hand side to be a set or map. Two. Okay, and this becomes the body of set value. I think we don't need return because that's what the match returns, and this should be right hand side. Okay, so then it's the same thing for map, right? Because map also has a contains. But it's contains key or something, right? Yeah. Slightly different. Different enough. Okay, now we're failing on map union. Map union. Okay. Is it saying that's not implemented? Oh no, it's just that they didn't compare. Okay, we did get an error. Inclusive or not is unsupported for map. Okay, so I just never implemented it. Was I about to and then I got distracted? Uh-oh. Error 5. My Roomba needs attention. I'll be right back. Okay. The Roomba gets stuck under in 3 places. Actually 4. There are 2 different rugs where it gets stuck on the edge of because it's dumb. It gets stuck under my son's gaming chair and it gets stuck under the dishwasher. Because those last 2, the gap is just like wide or and tall enough to get in, but then it just can't figure out how to get out. All right, so this is map membership. It should be like no, this is map union, right? So we need to have a union for maps. Actually, I don't even know if B-tree map supports it. I guess B-tree set has a union, but I guess B-tree map doesn't. No method name union. Okay, can we just do an add? Can I do like the left-hand side plus right-hand side? That would be sweet. No, plus is not supported. So I think we have to do it manually. Yeah, it's saying that there is no add for maps. Can I form the union of a map with a something else? Okay, so how would we do this add? It would be like a left-hand side dot iter map key and value to something, right? And that something would be well, after we map it to a new key value, let me think about this. I think actually I want to do like a join of 2 iterators, right? And then I want to do a collect. So can I do a join? Next to the iter. Can I do a join? Chain other. Takes 2 iterators and creates a new iter over both sequences. That's what I want. So I want right-hand side of iter. And then map those keys and values. Actually, I don't need to do a map, do I? I just need to do a cloned and collect. Cloned doesn't work on a chain. Oh, it yields 2 references. So what does it suggest I do? The method call chain might not have had the expected associated types. Does it give me a suggestion? Do I need to do copied and then clone? Copied probably doesn't know what to do with, right? Expected to be an iterator that yields a reference, but okay, it has inner references. So I have to just do this myself, right? Map key value. And I have to basically clone the key and the value, and then we'll collect those. So it'll be key.cloned clone value.clone. And then collect those. There we go. So iterate the left-hand map. So we get keys and values from the left-hand side, and then we chain it with the right-hand side. So we get all the left-hand side's keys and values, followed by all the right-hand side's keys and values. And then with each one, we clone the key and the value, and we'll let collect do the work. So the way it works is it just collect just stuffs things into this new map, right? And if it takes a key and a value and it stuffs it in to a slot where there already is a value for the key, it just replaces the value, which is exactly what I want. I hope. Yes, we passed all our tests. Yes. Cool. I think we have only vector to go, right? Just vector. Vector by itself is easy. The hard part is if I want to construct vectors by parsing in loop context, and that's going to be the fun part. Let's do the boring part first. So let's just take set again and copy it to vector for the tests. Set this. Copy paste. Name it vector. Go to tests. I'll say mod vector. I don't know why it ran. I must have misclicked. I didn't mean to run and debug. Close. All right, back to vector. All right, so this is going, we don't need a B tree set anymore, right? This is, so all the sets, test set is going to turn into test vector. All of these constructs become left square bracket, and all these become right square bracket. What am I currently building? Hey there, Gartuals. What I'm currently building is a general purpose decoder. I call it the DataDisintegrator. So it pulls apart bytes and figures out what they mean based off of a format that you write. So in the end, I hope to get something like Wireshark. And I'm not trying to duplicate Wireshark for any real purpose other than to have fun. So just for fun, making my own tool that's kind of like Wireshark, but in Rust and more generic. So like with Wireshark, you can drop in a binary file that's just a sequence of network packets, and it will figure out where the packets are, and you can click any one of them, and then it'll show you what's in the packet, and you can click any field of the packet, and it shows you where it is in the bytes. So kind of like that. I've been using this format, like an image decoder example. So this is what the language I invented looks like. So at the very top, you'd say, well, I'm going to be dropping in an image, right? So when I do that, look ahead as a string 24 bits. And if that string is GIF, then we're looking at a GIF or a GIF, however you want to pronounce it, right? Otherwise, we don't know what the format is. So conceivably, I might have an else if something, then maybe it's a JPEG, right? Else if something else, it's a bitmap or a TIFF or something like that. So you can nest them. And what that means is if this is the overall image, then this is a part. So this being overall GIF or GIF, a part would be the header, a part would be the trailer, and then we'd have some data blocks. We'd have a logical screen. The header has the signature part, which is the thing we did a look ahead to find, and then it has a version number, which matches if you actually look at the file, right? Starts with GIF 89A. So if it matches that, it's a GIF file, right? A GIF or a GIF. And then logical screen has a descriptor, which has the width and height. So all of these things the tool would be able to figure out based off of the format that we've described. It compiles this into an abstract syntax tree and then does an in-order traversal of it along with the data. So it's kind of walking this data structure with this data to figure out what the data means. So like as it's walking, it says, okay, first let's look for the header. Okay, what's the header? First we look at the next 24 bits from where we are right here. And we say, well, those 24 bits is a string, GIF, right? If it's not, then it's an error. Then the next 24 bits is another string called version, so 89A. If it's not 87A or 89A, it's an error. And we have a little interpretation map here. If it's 87A, it's the 1987 spec, 89A, 1989 spec. The overall value of header, whoa, I didn't mean to do that. The overall value of header is whatever we got for version. So that's what return does. We don't actually do anything with the value other than say that it's a part of a GIF, right? Or GIF, however you want to pronounce it. So after the header, that means starting at this byte is going to be the first byte of logical screen, which is the first byte of the descriptor, which is the first byte of the screen width. So indeed, if you mouse over this, it says that it's a 300 if it's little endian. And then the next 2 bytes would be here, which is also 300. So it's a 300 by 300 GIF. And if you're curious what that GIF looks like, I can show you. It looks like that. So this would continue to parse until it knows what every byte means. And then what do we do with that knowledge? One thing we could do is like Wireshark, we could just let you click on a byte and it would show you what it means. We could also use it to actually show the image if we wanted. Thank you. So there's a lot of things you can do with the tool. I'm just doing it for fun. I like the idea of like dropping in some binary data, like, like that, only I guess because I don't have it open, I have to do reopen, right? Open with hex editor. There we go. So I like the idea of being able to drop something we can't read in a hex editor into something like a super hex editor and say, well, this thing follows this format. And so it would not only show us the bytes, but it also have like a panel to the right or the bottom that says, well, these bytes mean this. Here's the header, and here's the width and height. And over here we have the global color table. And oh, here's the LZW compressed data blocks. And if you scroll to the bottom, it would say, well, that last byte, that's called header or trailer, right? So that's what I'm aiming for. So a little bit more depth is because this is a domain-specific language, that's just a fancy way of saying that I invented my own language. It means I have to have a compiler for the language, right? So 2/3 of the app are turning the program into a token stream and then matching that token stream with a grammar to form the abstract syntax tree, right? You could think of tokens as like the word image is one token. The left brace is another token. It's a punctuation, right? Then the word next is another token, right? The string GIF is another token. So it's just kind of compressing it's removing the white space between symbols and names and stuff, and then identifying what kind of thing, like this is a string, this is an identifier, else is a reserved word, those kinds of things, right? And then those we call tokens, and those go into a grammar, which it's a bunch of rules. And so here are some typical rules. Like here's how we make any place where we want an optional comma, there are 2 ways to match an optional comma. Either we have nothing or we have a comma. Either way, we're the interpretation of that is nothing. Now, a key value, there's only one way to construct a key value, an expression, colon, and then another expression. You can kind of see they're like the rules for how things are constructed. So a key value is constructed from two expressions with a colon between them, right? An expression list is parentheses. Oh no, that's an optional expression list. Wherever we might not have an expression list, we can either have nothing or we can have parentheses. And if we have parentheses, there's an expression list in there. An expression list, and here's where it gets fun. An expression list can either be nothing, so it's no expressions. It could be one expression, which is a vector with one element, or it could be itself recursively, comma, one more expression. So this is a recursive rule. We would hit this rule over and over again for everything in the list, building it from left to right. If I swap the left and right here, we would actually build it from right to left. Oh, well, thank you, Adjective Allison. I'm really just regurgitating all the knowledge I already collected. So it's not like my brain is coming up with this. I'm just like I'm playing it back from what I've built up. Plus, this stuff looks difficult at first, but after you played with it for a while, then you kind of just get used to it. It's just a different kind of syntax, and the concept of grammars is something you just get used to, I guess. Compiler sounds unapproachable and arcane, and like you have to have a five head brain to do it, but if you just like reduce it to like one concept at a time, which is what a compiler class would teach you, it's very approachable in small steps. Am I a teacher? I like to think of myself as eventually being a teacher because I like teaching, but I am not technically a teacher. You could listen to me for hours. Oh, thank you. That actually is a stretch goal of mine in life. You know how we talked to like in when we're planning things at if you're like an engineer or a designer and you think of like, well, you have your goals like that you have to meet, and then you have your stretch goals, like things that would be nice if you could do. Being a teacher for me is a life stretch goal. I don't have to do it. I'm not expecting to make any money off of it, but I think I would have fun doing it. And so I'm kind of doing it while streaming, aren't I? The only problem is it's not official, and I don't get to see your lovely faces. Okay, so where was I? Let's go back. So yeah, I built up the compiler parts. So in a sense, all of this stuff goes into memory, into a big data structure that we're just walking through it step by step. So what I've been working on today is like when we get down to building, what is it? Like this thing that is called a map because it has 4 things in it. It has 2 keys and it has 2 values. It's like a lookup table or a dictionary. If you were to ask this thing, give me your value for 87A, it would return you 1987. If you asked it, please give me the value for 89A, it would give you 1989. If you asked it, do you have X, it would say no. And if you asked it, do you have 1987, it would say no. But if you asked it, do you have 87A, it would say yes. And then you'd have to ask it, well, what is 87A? And it would say 1987. So this construct, I just implemented this, right? So it has to collect keys and values and put them together. We represent it in Rust using the B tree map. Stands for binary tree used as a map, because the binary tree is just a conceptual like how you organize multiple values together. And because of the fact that we have 2 kinds of things, we have keys and we have values, and they have a relationship. You use the key to find the value. That we call a map. A set is a degenerate form of a map. A set is really if you just have keys and you don't have any values. That's a set, and that has mathematical implications. So sets can have operations like union, intersection, difference, all that stuff. And I'm not going to go into that math because then I'd be spending all night explaining it. So there's really no difference between map, dictionary, lookup table, but hash map means something special. Hash map means you store it in memory using a hash, where you take the key and you run it through a function and it gives you a number, and that number you use to find it in memory. So let's say this is how a hash table works. Let's say all these lines are locations in memory. Okay, let's make 25 of them. Let's say that we had a function that could take any string at all. It could be empty string, it could be a million character string, and it can reduce it to a number between 1 and 25. So this is called a hash table, and the number you get from taking the string and running through the function, that's called the hash. And sometimes the function itself is called the hash function. So literally, when you say store a string hello, it would say, okay, run hello through the hash function to get the hash of hello. And let's say it's 10. Then we would store hello there. Okay? So a hash table is just in memory. You have as many slots as possible hashes, and then you store your values there. If you're not hashing with your format, does that lead to issues with duplicate keys? The way, instead of using a hash table, I'm using a binary tree, and a binary tree also cannot have duplicate keys, because with a binary tree, you have a parent node and you have a left and a right child, and the child cannot have the same, neither child can have the same value as the parent. So as you're walking the tree, if you find the key in there, it's like, well, there's no space to insert it again, because it has to be there. It can't go left or right. Hash table is a little bit different. You can have, in fact, you're going to have, if I were to insert more than 25 things into this hash table, you're going to have collisions. And you'll have them either sooner or later. You might have world up here, and you might down here, this might be where you put X. But let's say lulz also hashes to 10. Then do we just put it there? And the answer is yes. So in a traditional hash table, well, not traditional, in a typical hash table, you don't have one slot in every position. You have a list of 0 or more. And then if I ask you the question, is lulz in the hash table? It would say, well, let's look up the hash of lulz. It's 10. Then we have to go to the slot 10 and we have to walk and actually compare every string to lulz to see if it's there, because that's not lulz, but that is. And that's called a hash collision. And it's okay for most hash tables, because you allow the slot to have a list in it. So the performance of the hash table has certain caveats, right? So it's usually very fast to hash a string, to hash anything, to compute the slot, right? But if a lot of things hash to the same hash slot, if they all have this, if everything has the same hash, like let's say these all match, because we have a really bad hash function, right? Then it's going to take longer to find anything in this list, because now you have to do 4 comparisons instead of 1. So the goal of a hash table would be to find a hash function that evenly distributes your inputs. So you use so you like even it out through all the slots. Ideally, you want to have either 0 or 1 thing in every slot until you have more values than you have slots, and then you start to double them up. And then the opposite, the worst possible case is everything hashes to the same value, and then it really is, your hash table is no better than a list. You have to look, order n. You have to look at all n values before you can know if it's there or not, right? So I'm not using a hash table, but that's what a hash table is, sort of how it works. I've been using B tree, that's binary tree, another kind of elementary data type. But so instead of computing the slot and going straight to it, you basically are going down a tree where you could either go left or right on each step, and you'll, like, let's say you're looking for a 5 and you start at 7. It's like, oh, 5 is less than 7, so you go left. You'll hit a 3. Well, 5 is greater than 3, so you go right. Then you hit 4. Okay, 5 is greater than 4, so you go right. And you say, oh, there's 5. Or there's nothing, and then that means that that right path is where you would put the 5. And this stuff is, if you ever take like introductory like data structures or algorithms, they'll teach you this stuff. Hash tables and binary trees are used everywhere, and they're pretty basic. So they're going to be like one of the first things you learn. Like if I asked ChatGPT to explain a binary tree, or if I just typed in binary tree, there's a ton of things. Like Wikipedia's got an entry, looks like Geeks for Geeks has got an entry, and they'll have really nice pictures and everything. There we go. There's a binary tree. So you're looking for 7, right? You would go and find it there. I guess this one is not ordered this one's not really ordered. But the structure is like this, where you start at the top and you go either left or right. So that means this one, there's a slot open to the left, right? And this one, there's a slot open to the right. This one has a slot open to the right. These all have both left and right open. And usually when you're making it searchable, you sort it so that all the things on the left are less than the parent, and all the things to the right are greater than. This one wasn't ordered because 7 is obviously greater than 1. They probably have like an example of a sorted one down here somewhere. Wikipedia is sort of like verbose. It's not the best way to learn it. But yeah, pretty elementary. Well, that means, Adjective Allison, work is your school. You're just picking up what you would have picked up at school, just a more practical context of it. You're going to end up picking things up that you need to know. And instead of learning 10 things and only needing 3 of them, you're going to learn those 3 things on their own, which can be harder because sometimes to learn 3 things, you need to learn 4 other things first. So if you're like, I have no idea what a binary tree is, and then I say, well, in order for you to understand a binary tree, you need to know how data can link to other data, what a link is, right? Because when I was showing that just now, binary tree, it didn't remember I was showing it. When I'm showing this, like, you might not know what these lines mean. So in order to fully explain a binary tree, I'd first have to explain how, like, what the circle means and what the line between the circle. And I'd have to say, well, the circle just represents one, like one thing, a number, a string, something like that. The line represents a relationship between 2 of those things. In this case, the relationship is parent to left child. Parent to right child is the other line. Then I can build upon that and say, well, now I can explain what a binary tree is. It's a structure where you have every parent has 2 children, and each child has 1 parent. So that's why it's binary. Binary meaning 2. So if you're learning at work instead of learning it at school, you just learn it inside out. You start with a thing you want to know, and then you have to learn the prerequisites of that first. Auto modbot, whatever, didn't like pain in the ass. It's been a pain in the ass. Why I ended up in SRE DevOps instead of systems level engineering, because it's easier to pick up. Yeah, because if you don't know okay, and explained another way. Let's say that we have a knowledge relationship like this, right? I don't know why I thought that was Python. It's just me doing plain text. To know C, you have to understand B. To know B, you have to understand A. So if you're on a job and they ask you to work on C, you'd be like, I have nowhere to go to start. So you have to have someone who already knows all 3 of these say, oh yeah, I can teach you C, but first I have to teach you A, because you need to know A to understand B, and you need to know B to understand C. And they would just focus on teaching you A, B, and C. And let's say at school, you learn A, B, C, D, E, And also, before you learned A, you learned 0 and 1, right? These are just things you might learn. So you come out of school knowing what 0, 1, A, B, C, D, and E are, and maybe you thought that B was interesting and E was interesting, but you fell asleep during C and D, and so that's why you got you failed. Maybe you failed the part of the test that talked about E, but you were good with the other ones, right? That's how school works. When you get to work on a job, they're like, we need you to know C. So you go to your mentor or your boss, and they know that you'll need to know A, B, and C, and they'll teach you just that. You'll never know 0 and 1, and you'll never know D and E because the job doesn't need it. Now later, after you do your work, you might talk to someone else who says, hey, there's this cool thing that called D that I can teach you now that you know C, right? Or someone else might say, you were taught A, but did you know that A is based off of 0 and 1? And then, so there's like other learnings that you won't pick up at work unless you kind of look for them, or like, yeah. School gives you a holistic, like, here's everything, kind of like throw everything in the wall and see what your brain can hold on to. Whereas work is very focused on practical use. And so you'll only like be exposed to the things that you absolutely need to know. For me, I learn best actually hands-on, and so I don't like school as much. If I need to learn something, the school approach, and you'll see this happen on stream, I'll go to a tutorial or something, and then I'll just be like, just get me to the answer. I want to take the answer, and then I want to understand the answer by trying to use it. And I think that's for me. I think that's because for me, like, I never really liked learning the whole sequence. I like to. I'm a more practical learner. Do the same thing. Yeah, but some people are different. Some people like to learn every aspect, and then they're like, can use any piece of it. I think I just don't have the memory capacity to remember all of those things, you know? Okay, so where was I? I have map. Oh, we're gonna do vector, right? Yeah, so I was gonna have a vector. Doing what's called test-driven development. So I write the test first, and then the test will fail at first because it should hit this line of code that the to-do is marking. It should hit this to-do. If we ever hit that, we get a not implemented panic, and then we'll know that the test is worth something when the test hits it, right? The test is exercising a code path we haven't implemented yet. Okay, so yeah, this is just a basic thing. We're building a vector. So I should get vector, and I think we're just going to use vec internally, right? So it'll be, that's the structure it will have. So we don't have vector yet, which is fine. We will have it soon. So what's this? Not, oh, the not empty. Right, we're going to use logical and for whether it's empty or not. So that should still be true. This should still be false. Vector add non-vector. We should allow that. That should add to the end of the vector, right? Like that. Add it to the end. Oh, no problem, Adjective Devalson. Have a good night. So add vector should work, right? Actually, do we want to allow adding sets to vectors? I mean, it should just take every element of the set and add it to the end, but then the order would be arbitrary, right? Yeah, so what's interesting about this is that these don't actually collide anymore. We'll have independent 69s in there, like this. Right? And then vector union, I think, doesn't make sense. That does not make sense to me. Because adding is just concatenating to the end. Union implies that we're like mixing them somehow, and then, yeah, vector doesn't make sense. deleting that test. Intersection, same thing. If you want a union intersection, you use a set, not a vector. Subtract doesn't make sense either, so we're removing subtract. Same thing with the subtract member. I think if we wanted to remove stuff from a vector, I would probably just make a built-in function to do that. Equal false. Okay, these are not equal. That's correct. Equal true. This one, they have to be in the same order. So let's make sure that equal false wrong order. So this should be false. And this is just true because they are in the same order. True. Vector not equal false. That's true though. Not equal. These got reversed, I guess, by accident. So this is not equal false wrong order. No, it's true non-order. False. Oh, it's true because it's the wrong order. And I want to make a version of that where it's the correct order. Not equal false. Yes. So that has to be exactly the same elements in an order. So it's false. Okay. Vector membership. I suppose that's like searching, right? So we should support that. Membership false. It works the same way, right? Not. Oh, we're going to have to update that one in set, right? Yeah, let's go do that now before I forget. Set. Not a set, map, or a vector. Okay, go back. All right, so these won't compile because data value has no such thing as a vector. So let's add it. Vector, value. You might wonder to yourself, hey, isn't that recursive? And the answer is yes. If I actually had value here, it would actually be a problem. And the compiler is going to tell me that it's infinite size. And you'd be like, what? How the heck does that have an infinite size and that doesn't? Well, let me explain. This has an infinite size because the compiler knows that any value of this type could be any one of these variants. It could be a vector. If it is a vector, then that means that the memory for this is going to be the same number of bytes as its parent. That's impossible because not only do we have the value, we have the whatever it is that tells the outer one that it is a vector in the first place. So then we get into a situation where like x plus y equals x and x is greater than 0, which is impossible, right? That's impossible. This actually should be y. That's impossible, right? If we add some non-value number to x, it can't be equal to x anymore. The only way that that is actually possible is if x is infinity. So really, this is sort of a misleading diagnostic, saying it's infinite size. Really, what it should say is that a type can't a value for a type can't contain itself. Well, maybe that's why they don't say it that way, because it's hard to say. So why is it that I'm allowed to say this then? Because of a sneaky trick. So the trick here is that a vec or a vector or an option actually, no, not true for an option. A vector or a B-tree map or B-tree set they all do one sneaky trick, and that is that they do not, the memory for the vector and the memory for the values inside the vector are not in the same place. A vector is really just, if you think about it, not if you think about it, if you study what a vector is, it's sort of like this. You have a pointer to the elements. In this case, like, let's just say it's some t, right? Where a structure is a vector is a generic. And then you have like a number of elements, usize, right? So that's the memory layout of a vector is two things, a pointer and a size. Where does that pointer point to? It points to somewhere else in memory. So that way, it's called indirection. It allows us to have one of these inside of value, even if t is itself a value, because it's really the outer value points to some other inner values. They're in a different area of memory. So the size is known and it's not infinite. We know the size of this is the size of a pointer plus the size of an integer. The size of a value is the size of the largest variant, right? The sneaky trick is that it doesn't matter what t is. The size of elements is the size of a pointer and has nothing to do with t. Now, practically speaking, the memory for vector map and set, like the inner pointer where it points to, is to the heap. So all dynamic memory allocation in Rust is kind of hidden away inside these types like vec, btree map, set. You might see box. If I could type this correctly, box. You might see RC, ARC. One thing that these all share in common is that internally they have a pointer to t. Box has a pointer to t that can't be null. RC has a pointer to t that can't be null, and it also has a reference count. ARC has a pointer to a t that can't be null, and has a reference count that you can operate on from multiple threads. So it's like the multi-threaded version of that. The equivalents to these in C++ would be a non-null pointer, a smart pointer, and a shared smart pointer. Which I think in C++ shared pointers you use shared pointer for both of these, right? And box you'd use unique pointer. All right, that said, I'm in teaching mode. Why am I in teaching mode? I think it's because Adjective Allison pumped up my ego about being a teacher. Okay, so I defined vector type, so I got to chase down the errors now. All these places where we don't have vectors. Yeah, see, like, you shouldn't feed my ego. I'm just gonna like become someone that I'm not. Vectors cannot be cast to usize. That is true. We need to implement the display trait. It's gonna be kind of like set, right? In fact, let me have it fill in the missing arm, and then I'll just copy the code for the arm and replace the to-do with that. There we go. And then this is values, and we don't want that construction just becomes square bracket. And this is a problem. Why? Oh, I made a mistake. That's because I made a mistake, because this should not be a vector of values. I want to leave space for nil, because my language has nil, so that's an option value. You can have a nil in the list, an empty slot. Very important later, actually. So, what happened to the display trait I was working on? Oh, it just builds, right? Comma separated list with square brackets. So yeah, you can make a noob question. Why is noob not allowed by automod? Okay, noob is now a permitted term. What's a noob? What noob question do you have? Okay, so to convert a vector to a bool is to ask it if it's empty, right? So it's the same as set. It's possible to write a stack push pop using just lifetimes? Like a stack of lifetimes? Those are sort of incompatible things. So I think of stack as a data structure, and I think of lifetimes as knowledge that the compiler has about how long a value is accessible. A simple i32 stack wouldn't need lifetimes because data structures own their values typically, unless you're talking about a stack of references. Then the answer is that in Rust, when you have a data structure that has a certain number of things, like where should I go for that? Like a vector of somethings, you could have a reference in there, right? That's fine, but because you don't know at compile time how many references you have, there's a constraint placed on this that the lifetimes all have to be the same, right? Oh, my Roomba got stuck again. Hold on. It's the Roomba trap. It'll fall over there. I don't want that. Roomba fell into the Roomba trap again. Stack has an optional node. Node has a next node. Okay, that's not a stack. That's a linked list. When you say next, so when you say like that you have some kind of struct, and then you have like something like the next is another, we just call this thing like a node, like a reference like that. This means it's a linked list, right? It's a self-referential reference to another value of the same type. So now we're talking linked list. Like this, right? You have some value that has a pointer to another value of the same type, which has another pointer, and then at the end, it doesn't go anywhere, right? Well, a stack can be implemented using a linked list, but it's technically not a stack anymore. It's just how you implemented the stack internally. So let's just distinguish between the two. A stack is really the same thing as a vector. Actually, you could make a stack, right? Maybe there is no stack type. Basically, you can use a vector like a stack. A stack means that you can add a value to it, and you can take a value out of it. And whenever you push, all the values move down one slot. And when you pop, you take the first one and all the other values move up one slot. So that you can do that with a vector. I think internally they optimize away the moves or something like that, right? Or maybe it's list. Is it list? Linked list. See, there's a linked list in Rust. So they've implemented it for you. So you could make a stack using a linked list, or you can make a stack based off of a vector. And a linked list would maybe be more efficient, right? But if you wanted to implement your own, sure, you can do that. But you'd have to solve this problem about the self-referential structure. I'm missing a bit of your chat. So, Vincent, or is it Vicent? So the problem about learning, you use the three words that there's a special combination: learn, Rust, and linked list. Whenever these three things come together, there's big warning. Think alarm bells, big red lights flash. Stop, stop, stop. Warning, warning, warning. This is always a bad combination. Learning, Rust, linked list. The problem is with usually the way linked lists are done, they're done with pointers that are nullable. It's really hard to do that in Rust. One naive attempt to do the next is to do option. Problem with option is it's not a nullable pointer. It's really a union between empty and the type node. So what you really want is some kind of like nullable pointer, right? There is no such thing in Rust because of one of the fundamental things in Rust is memory safety. If we made a type that's nullable, it's fundamentally unsafe. So you could do a raw pointer like this, but I believe that is unsafe. Oh, okay, I have to actually say it's like mutable or not. So I'd say mutable, right? Problem is that this is no longer a safe structure. You can't operate on the next pointer without taking the safety harness off in Rust. And when you do that, now you've thrown away lifetimes. So if you wanted to learn, if you wanted to learn all three of these things at once, it's actually impossible because to do a linked list properly, you want the raw pointer, and then you no longer have lifetimes. Lifetimes apply to references, and you can't make a linked list with references. Let's look at how they did it in the standard collections. So they have something called a non-null, option non-null, and I think this is an unsafe type, or it's some kind of weird internal type. Yeah, it's the huge caveats, right? I think like it's fundamentally unsafe to use this thing. All of its, I think all of its code is going to either be there's a safety check or the method itself is unsafe, like that. See, unsafe, right? So you can do it, but you're taking the safety bolts off, and you're no longer dealing with lifetimes. You can see this thing has no lifetimes. It's just an unsafe implementation or unsafe structure. So yeah, don't do all the four things at once because that's impossible. These three are alarm bells because linked lists are very hard to do in Rust because you'd have to use the raw pointers, which brings in safety and unsafe code and all that, and you don't want to do that while you're learning. Don't learn Rust by trying to do a linked list, please. It's like the wrong way to learn. When we get to the idiomatic part of what though? So there are three things. Lifetimes. Which thing do you want to get to the idiomatic part of? Like idiomatic Rust, idiomatic linked list, or idiomatic lifetimes? Because these I consider these three fundamentally different things. So Rust itself it's just a collection of the idiomatic ways to do different things in Rust. One of which would be lifetimes and one of which would be linked list, right? The idiomatic linked list doesn't use lifetimes at all. It uses unsafe code. So you should not try to make your own. You should use the one in standard collections. Idiomatic lifetimes, since lifetimes is just a subset of a reference, then it's really just idiomatic references. And then I think that's kind of a broad subject, and we might want to know what kind of references we're talking about. Oh, are you talking about breaking down like idiomatic Rust into like the different things, like the common traits? That's just a huge menu, a smorgasbord of different things. So pick the thing you want to learn idiomatically out of that first. I'd pick something easy, Can you avoid lifetimes mostly? Yes. Lifetimes only are needed when you have references, and it's completely possible to make code without references. You just have to have, every time you have a value, it has to be owned by the code that's using it. So if you need to pass a value from one place to another, it either has to be copyable implicitly or you clone it. And you would avoid the traits that require you to use references, which you can, you're kind of limiting yourself because you can't make types that are orderable or equatable without having references. But if you ignore the fact that there are references in your arguments and just deal with them, you don't have to worry too much about lifetimes. It used to be in Rust that you had to have lifetime specifiers for these things, but they got rid of that. I guess that would be a B, right? Because by default, it assumes these have different lifetimes. But they got rid of that. They're like elided away. They're hidden away because you don't need, as a programmer, you don't care. Can you avoid or return it? When you start storing lifetimes inside of structures, when you start doing that, it won't let me do that unless I give it a name, and then I have to say the whole structure is tangled up with a lifetime, and that's okay-ish. It's just that that's going to start polluting your code, and you're going to have weird problems when you have like methods of that type, because now it's like has to be a lifetime there, and which reference is that lifetime for, right? Is it for self, or is it for other, or is it for both? You reach a point where these can no longer be elided, and then you have to actually be explicit and say things like that. And then it gets, if you watch my stream and I start to do that, I get myself caught in problems with that. My advice is avoid lifetimes until you actually need them. Rest is a whole new puzzle. Yeah, approach it one step at a time, and if you know another language first, it helps. So you learn the part of Rust that matches the language you already know, like it's Java or C or something like that. There's Rust equivalents that are in common. Once you know the common parts, then you venture out into the new things like lifetimes. But yeah, there's a general rule. If you get stuck with a borrow checker or you have references, clone is your friend. Exactly what Nightshade Dude just said. Remember that. When in doubt, clone it out. Clone is your friend. Okay, but then remember in the back of your mind, clone equals inefficiency. You're going to make your code less efficient because clone is making a duplication of your data, and it has to allocate memory for it sometimes, most of the time. But what it does is it sets up two independent lifetimes. So that's less performant because now you have two values where you had one before. You need double the memory, but now since they have independent lifetimes, you don't need to actually specify them anymore. Everything is owned. When a value is owned, then you don't need to share it, and you don't need to have a reference to it. You just have it. All right, let's move on. So I need a ranking for vector. Hey, look, it's alphabetically next anyway. How convenient. Okay, this is the tricky one, right? Because we can't do we can't add a match arm because it's not smart enough to do that for me. Oh, we're just going to do the same thing. Cannot convert vector to unsigned integer. Same thing for this one. Map vector. First learned C in college, and they did a lot of C#, but don't like object-oriented. A lot of JS, but mostly for functions. Yeah, so learn the C subset of Rust. You'll see me do stuff that you could do equally in C, right? Well, not this enum stuff, but like, I don't know. Problem is that I'm doing a lot of type stuff, and that's going to look different. What's something that's going to look similar? Like, I know, the test framework for, yeah, this buffered bitstream. Here we go. This should look familiar. We're doing right shift and bitwise and we're doing some math. We're doing the min, right? Minimum of two things. This is shifting left one and subtracting one, and that makes us a mask, right? So that when we do that, we're masking. So this is almost the same thing in C. The only thing that changes is you get rid of the lets and you replace it with a type. You'd say like int byte offset equals offset, you know, some other offset. I guess the self dot becomes and I guess it would become an arrow if self was a pointer, or maybe an underscore if self underscore offset was an argument or something like that. But yeah, other than that, like the structure is very similar to C. So this should be easier to grok, right? So the differences are going to be in Rust, you don't usually say what the type is. If you wanted to, you would do it here. You'd say like that's a 64-bit integer, right? Whereas in C, you would take that and you put it here, and then you put it int underscore t there. That's the C equivalent of it, right? And those you'll pick up fairly quickly. It's like, okay, I need to put a let in front, and I don't need to put the type, but if I do, it's a colon and then the type. And then the type names themselves are just abbreviated forms of what you're used to, right? Okay. Cannot convert a vector to decimal, right? I have a feeling that I was in the middle of writing some code and I didn't complete it and I got distracted. But you know what? I'm not going to worry about it because if that happened, my unit test will catch it, right? Vector. All right. 14 errors to chase down. Okay, add. Add, we will support just like we do for set. Super vector. Clone the values and then it's push back. That should be super vector. Super vector. Divide undefined, right? Dividing vectors is undefined. Equality is defined. If the right-hand side is also a vector, we just compare them. Otherwise, you can't compare them. Greater than or equal to. It thinks I'm dragging sometimes. Moving my mouse while I click makes it think I'm dragging. Oh, I heard the Roomba's successful victory sound. Boop 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 boop. The battery life is like now only an hour and 15 minutes. It used to last like an hour and a half. Vector. Order of vectors is undefined. Dirt. Somewhat abolished. It's not perfect. Like, I didn't let it in the office here, so there's still dirt around here. I'll have to like let it go tomorrow. So this is sort of tedious because we have a lot of these different operations that we defined where vectors are undefined. Can't multiply vectors. This is correct. Does not make sense. Although if we ever did define what multiplication means in my language for vectors, that's where we would implement it. Okay, we can compare them if they are both vectors. Otherwise, they are not comparable. Subtract is undefined. Unlike set and map. Subtracting vectors is undefined. Oh yeah, I had to, no, this is actually, this should work. What's wrong with this? Oh, did I change it to linked list? It's because I'm talking about that, right? I forgot about that. Okay, only one error and one warning. We don't actually need linked list. We were just talking about that. And push back. Is it just push? I'm thinking C++, it's push back, right? Hey, look, no warnings, no errors. That means it just works, right? First try? Nope, not first try. Oh, because vector construction is not implemented yet. Not implemented right there. There we go. So let us implement it. This is similar to a set. So it's going to be construct vector from expressions. And we can just copy construct set to construct vector because it's almost identical. We're going to iterate the expressions, map them to evaluate and collect the result. The only difference is that it's vector and not set, and the collect, this type is going to be different. It doesn't show it. Bummer. But yeah, the type of this is vector of data values, and this is hash set of vector of data values, optional data values. Still failing vector construction. What did I do wrong? We just panicked here. Oh, the comparison. Right. We need to be able to compare vectors. Done. Easy. Okay, so vector construction worked. Now we're doing vector empty equal to false, or equals returning false. Okay, the vector empty is the Boolean cast, right? There's add vector. Where's I'm not seeing the test that failed here. Oh, vector empty passed. The one that's failing is vectors being added together. Oh, it added it. Okay, I see what happened. It added it as an element. Technically, that's actually what I do want. I do want to be able to take a vector and add it as an element of another vector. So maybe I change my test then. Then I had the same problem with set, right? With set, didn't I make the same decision? That set add set. Yeah, it has a set as a member of another set. That's right. I had like intersection, or no, I had union if you wanted to combine the sets. I wonder if I should do the same thing with vector. If you do a vector inclusive or, it just concatenates them together. Actually, that makes sense, actually. I think I'll do that. So let's do the same thing for, actually, it's right there, vector. Right, add non-vector, add vector. Yeah, so this should do one of these right here, nested with a sum in front because it's not nil. Okay, that should make that test pass, but then I want to have like vector union. Can I copy that from set union? Yeah, exactly. So copy that, put it here. Vector, no, don't run test. Vector union. There. Yeah, so this should be vector vec, and this is the difference between set and vector. It should glue them together at the end there, maintaining the order. So this is going to fail, right? Saying inclusive OR is unsupported for vector. So now we can support it by going to inclusive OR. I think it's just going to be like set, right? Oh no, it's going to be like map, I think. Actually, doesn't vector allow me to just glue end to end? Can't I just say, okay, value vector, can I just say like LHS dot clone dot append? Oh, that only works with the mutable right-hand side. Well, I could just do the same way, iter chain, and then this is map. Well, actually, that's just cloned. There we go. Cannot form unit vector with something else. Okay. Test. We go. Okay, so everything's working except for membership. Okay, and it just doesn't work with vector yet. So that's in. Yes. Okay, so then we're adding vector. So contains works for vector. It just does a linear search, right? So that should just work. There we go. 469. Is it party time? We have no to-dos left. Woohoo! So we still have these to-dos. Now we get to do the fun stuff, right? Skip that one. Skip that one. Skip. 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 Aha. Here we go. It's this to do. Use the indices here, including the ones implicit by being in a vector context. Okay, so that means references should be allowed to go into vectors and pull out pieces. Also, we should be able to index a set or a map. So if it's a vector, the index needs to be castable to a usize. If it's a set or map, it has to be, it's just used as is to look up the set or the vector, right? And for a set, an index will give us a true or false. It'll tell us it's in the set, right? And it's only if it's a right-hand side. Actually, I guess we don't need to support indexing of a set. So we'll support indexing of a vector and a map. So what do we want to do first? How about vectors first? So we have do I have a vector test suite? I do. All right, so let's add it at the end. So this is going to be vector indexing. So yeah, this would be like some kind of vector. Actually, I can even make it simpler. Just return. We have a vector construction followed by an index. That should give me 42. Unsigned integer 42. And just to be like even more what was I gonna say? to make it even more fun, I can have a multi-dimensional. So now let's pick out the zero index inside of that inner vector should also get to be 42. Nested. Yeah, that's a good thing. Test out of bounds. Thank you for pointing that out, because I would not have thought of that. Hey, you have a useless internet point. Congratulations! That is your first useless Raimu internet point. Okay, so indexing, the couple cases, right? Bad index. So we might say lulls, right? So in all of these cases, we will get none. Actually, we'll just get an error. So we should just assert that foo is in error. So bad index type. Bad index value. Well, bad index value out of bounds. Actually, there are two of them. So too high. They'd be like 2. And then we should also support signed integers. So too low would be like negative, if any kind of negative number. But we should also allow a signed index. Indexing signed. It should be a +1. Okay, so we got a bunch of tests now. We're gonna fail them all, right? Yep, we failed all 5 of them. Okay, well, let's go implement them. You can see that it's probably gonna hit that it didn't understand the token. Actually, that should have worked. It says that it's the token's unexpected. Oh wait, references. Okay, I built the test wrong. I actually don't allow that in expressions, only in references. Yeah, okay, I have to redo these. I have to do it the way I was about to do it. We make it and then we return a reference like that. Can I do it with... That's going to select too much. How about we select those? Okay, that's good. Go to the beginning of the line, delete, 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 x equal, and then let's select all of these again. That return x. There we go. I think I did them all. Yes. Okay, this one is like that. Yeah, I don't support indexing expressions. You have to index a reference, which is a kind of expression that begins with an identifier. So let's try again. It has to fail in the correct way. Yeah, so see, it's ignoring the index and just returning the whole vector right now. That's the indexing nested. This one failed because why? Oh, that's the same failure. Standard error. This one actually succeeded and it should have errored. Yeah, so I think they're all failing because we're just ignoring the index. Yeah, we're just ignoring the index. So that's good because that's where that comment was, right? Where was it? It's going to keep going back until I hit it. There it is. So this is where we want to use references, right? The part is a composite. If I use the indices, then we're going into a composite, a certain path into its either vector or map contents, right? So that means we're always okay, that means there's two possibilities. Either the composite's value is a vector or map. So this data component will either have a value that is a vector or a map, and then we're indexing into the value at that point. That means that we're no longer gonna it has to be the tail of the reference chain. The other possibility is the component is a vector, and we don't support that yet. Component is a single structure right now. To support vector context, I need to change the whole structure, and we're not there yet. -1 for less is actually useful. That's true. Think I should support that? So the -1 test, maybe that should return 42. Okay, you've convinced me. Give you another point. So this would be like -3. And then we'll have another test for indexing from end. So this would be like a -1 would give me, okay, I need to copy from here. To there. Actually, I tend to do this a lot, like not have an end of line there. Yeah, so it happened in two spots there and there. Fixed. Cool. Okay, so from end we should get 42, but if it's too low, then it's an error. All right. Second of many. So yeah, we're not doing vector context yet anyway. So yeah, that means that simplifies this. That means if we have indices, it needs to be the last step. So we should record. No, we should just check to make sure. Well, we're in an enumeration, right? So we should just set a flag saying like we've descended into a value at this point, right? Which means I should have a test for that. So let me go back to vector. Let's pick one of these error tests. This one. So something like if I did return x 0.y, that should be an error. Because it should not like that the path is indented yet. So this is test vector indexing extra path. So the moment we index into a value, that should be the end of the path. This is only going to be allowed if x itself is a vector component. and this selects a component, and this will go path into that component. Oh, hello, kitty. Hello, kitty. Come here. We have a kitty. We have a kitty. She tried to go eat my power cord just now. You tried to eat the power cord. That's right. She was sleeping on the other side of the desk, and she decided, I'm going to get up now. I'm going to go eat, and then I'm going to go eat his power cord. Okay. Now that cat has been dealt with. So I think for now we'll just keep it to where there's we're going to loop, but it needs to be the last step. So let's have that mutable we have a problem actually. That's the wrong type. That's the wrong type. Where is the reference actually used? Because I'm thinking maybe we use an enum where it could either be a data component or a value. Okay, it's only used in one spot. Evaluate reference to get a value. Right. Okay, so then what if I just change this to return the value? And it'll just always give us a clone. That makes sense, right? So yeah, let's change this then. This is now going to return a data value, an optional data value. Data value. Okay. So then I can actually do this. I can have like let mute value is none. And then we'll say if descending, well, if we've located a value, it's an error to not be at the end of to not be at the end of the path. So if value.isSum, then we are returning an error. Self on error. We can print the remainder, or should I bother? I can just, yeah, we have the path that we've been constructing, right? So we can say, actually, why am I typing when I can just copy paste? Cannot path into that, right? And then return an error. So then we, actually that should have gone there, right? We do it there. So if, hold on. Actually, the indices is all the way at the end. Because first we have to look up the child. Then from the child, if it's a vector, the indices. Okay, here we go. That's what it is. So this is like path into child. And this is if we have indices, path, well, if we have indices, then we're extract value. If we've extracted a value, it's an error to not be at the end of the path, right? And then there should be an extra one that if we still haven't extracted a value, copy the value at the end of the path. Exactly. So it would be like part, it would be okay part, well, I already wrote that part. Okay part dot no, not part, it's value. Okay value dot unwrap or else. This one takes nothing, right? The unwrap or else for an option takes no argument, right? So then it would be part dot value dot clone. Yeah, there we go. So it should know by now that value is an option value. Yeah, exactly. It's a double option because the outer one means have we selected one? Have we extracted one yet? And if we have extracted it, it could be nil. If it's not nil, then there's the value. Okay. I'm wondering if it was it a good idea to have option for none to map to nil, or should have had a value type called nil? That would have made a lot of things cleaner. Maybe I should go back and make it. I didn't want to do that because I felt like nil was like doing the same thing that an option does. Anyway, okay, so path into child, if we have indices extracted value, right? So this is where we're going to do it. If ref part dot indices is not empty, then we're descending. Then value, we have to do this iteratively actually. So value starts at, actually we're gonna have a value ref equal, this is gonna be mutable also. Yes, value ref equal, part dot value it has to be a vector right now, right? Let's just start with vector. So we'll do a match part dot value. Some data value. Well, I don't want to flatten it because the value itself inside of part is an option. So we actually want to clone that. So none becomes none, some becomes a clone of something else, or some clone. The unwrapper else means if we already had some value, it could be some none or some actual value, and we just want to remove the outer option off of it. If it's nothing on the outside, then we have to copy that's the implicit the value as is without descending into any part of it. And I shouldn't have used the word part because that's totally overloaded. Vector, right? Of values. here's where I'm going to put the loop. If it's none, we have a problem, right? Or if it's anything else. Should I have a diagnostic that says what the type is? I don't care. This is a diagnostic of like that it's not indexable. Path is not indexable. And actually we can say what the type is. So yeah, I do want to know the type. Some value is not indexable. Is that how you spell indexable? Define indexable. Yeah, okay. Dictionary says yes. So return it. Option data value does not implement display. Oh, it does, but I need to have the helper trait, don't I? I thought I did implement it somehow. How did I do that? Like, don't I print nil? That's, oh, okay, I did something like this. Okay, and I can't implement display. I can't do this for option value, can I? But I can put in my helpers. I think that's what I'm going to end up doing. Yeah, it's not going to let me do it, right? Because option is not defined in the current crate. But we can cheat and we can use our helpers to do this. And actually, that means that this gets reduced to just this. Hopefully. Not private value helpers. This would be a public value helpers, right? So it would be like function, I don't know, display. So technically I can't implement the display trait on option. And even doing it this way, it won't work, right? I guess we're gonna punt. So go back to the error here. So that we'll just have to figure out as an argument to format. So this would be like if let some value equals value, else nil. Then I'm going to want to do toString that one, which is ugly. Because this one is format. Well, it's value to string, really. It doesn't want to format this because I'm missing some punctuation somewhere. Right here. Comment that out for a second. Like there, I formatted it. Yeah, this is ugly. I don't like that. Especially that. The alternative is to repeat this twice, right? I'll just leave myself a to-do. Can we do this in a better way? All right. So if it's some vector, then we want to descend into this. Actually, this match needs to be inside of the loop anyway, right? So yeah. This is going to be inside of a big loop, right? So let mute part or value ref borrow the parts value. Then for index in ref part indices. Borrow that. Do that. And this will be value ref. Okay. And then if that is true, then we need to evaluate the index. Actually, I should have evaluated the index to begin with, right? Since that's an expression, we should let index equal self dot evaluate expression index question mark. Okay, so then it's of type option value. Then I need to match that. Because we allow two different types, right? Signed and unsigned. And it should be done inside of here actually, because yeah. Because if we're going to index maps differently. Okay, so then fill match arms. Let's assume we get an index. So like we'll put something in here like 2. Actually, I can just say it's of type usize for now, just so that the rust analyzer will help me here. So we need to catch if it's too big. Actually, I think I'm going to catch it internally here. So if we get out of here, it's a valid index. So that means just value ref equals value values index. I was hoping I'd be able to get away with that. Consider borrowing. Oh yeah, I do want to borrow. Unreachable statement only because of my to-dos. Only because of this, right? Yeah, so this is gonna be some index. And I'm gonna have another diagnostic like this one. Wow, this is getting really messy really fast, isn't it? So this is complaining about the index, right? Index cannot be used as an index to path. Yes. And I don't need this part. There's no index is an option value. Oh shoot. I do have to have that gross stuff. Okay. This is just index then. Okay, awful. And we're indenting like heck. So yeah, this is nasty. I'll probably want to refactor this out very soon into like another function. Anyway, that should be reachable. Oh, we haven't done the to do yet. There's actually 2 sums that I want to support. Data value unsigned integer index and signed integer index. Okay, so we want to do range checks on both of them. Right? So if index is greater than or equal to values.length. Then we're doing a diagnostic. Only it's a little bit easier. This one is it's out of range, right? Index out of range. Out of range for that. And I don't need this stuff. And this needs to return that error. And else, it's just index, right? Yeah, index as is. What's the problem here? Mismatched. Oh, shoot. This needs to be like as, okay, so we can do that, right? Let index equal index as usize. That should, you should always be able to convert a 64-bit int to a usize. Okay, cool. So then the signed integer is just kind of backwards, right? No, it's if it's positive, then we deal with it one way. If it's negative, then Vincent convinced me to do it another way. So actually I can just say if index is greater or equal to 0 is one way. And it's actually almost the same thing as unsigned integer. It actually is the same as unsigned integer. But then if it's less than 0, the way we do it is we take the negative index as the usize and oh no, it's the length plus that, right? So or I guess I can just say it's values dot length as an I64 and then add index, right? Can't, okay, the whole thing as a usize at the end. Well, only if it's greater than 0. Yeah. If it's greater than or equal to 0. No, if it's less than 0. If it's less than 0, then it's out of range. Otherwise, it's negative index. And I forget if I need the parentheses or not. I don't think I do, but just to be safe. So is that correct? It's the length as an I64 plus the index. So if it's like, if there's 2 in the list and you -1, it should go to 1. 2 plus -2 is 0. 2 plus -3 would be out of range. Okay, I think that works. We have an error though. Oh yeah, for this, it just returns I don't need a map anymore, right? So then evaluate reference is just dereference. So I can get rid of this and just call dereference for evaluate. This is just dereference. Look at that. Easy peasy. And then it actually compiled. I'm shocked and appalled that that compiled as is. Look how bad that code is. That should not have compiled. It doesn't deserve to be compiled. And why did I not need to make that mutable? Oh, I actually never did anything with the value, did I? So we do this like, we get this value ref, but I never actually use it. So it should be at the end, value equals value ref dot clone. Why is there an error there now? Expected an option value, found a value. Value ref is what? It's an option value. So shouldn't value be an option value? Yeah. So what's wrong with this then? Oh, it needs to be an option value. So this should be some value ref clone. There we go. All right. Ugly. We're gonna have to refactor that. But let's see if any of our tests pass. Okay. Is it gonna be first try? Nope. Unexpected token return? What? Can I go to that test? Yes. No, I can't. I have to find vector indexing. It looks like I have a bad program in there. Vector indexing. It didn't like the return. Oh, because I'm missing a semicolon. Am I missing a semicolon on all of them? No, just that first one somehow. All the rest of them have a semicolon. Okay, I really just want to run that test, right? Make sure indexing works. Hey, it passed. Neat. So maybe I'm confident that they'll all run. No, indexing from end failed. Indexing, well, did that mean this one passed? Cool. Signed index worked. How about the bad type? Lulls cannot be used. It actually double quoted it. Cannot be used. Yeah, I don't want to put quotes around that, right? Yeah, I don't want quotes because that implies a string. Path is a string. I guess I do want quotes around that because the path is a string. So we want to remember that's a string in the diagnostic. But index is not a string here. Unless we accidentally try to use one that's a string. Okay, lul's gonna be used as an index to x. Correct. Backticks? I wanted to keep it simple in that it uses double quotes only if it's a string. So in here, it's both a string, right? That's a string, and x, the path is also a string. And I just want to keep it simple. It's either a string or it's not a string. Too high. Index 2 out of range for x. Correct. From end. This one fails. We get, oh, look at that. So the negative didn't work. I guess it's out of bounds. Length is 2, but index is some huge number. How do we get a huge number like that? It's this thing, right? This thing is wrong. So that should have, turn it into a 2, and then plus -1 should have been a 1. Let's put a breakpoint there and see what's actually going on. Where are you, vector? Debug. Markdown and Rust uses it for displaying code. Yeah, so I'd want it for code, I guess, but this is an actual part of the program. So, well, I guess, yeah, what is code? Does that include like bits of the input because the input is a program? Okay, yeah, now see the indentation is working against me. What is index? Index is -1, and then values is 2. So what is the index? It goes to 1. Okay, so that's correct, right? Oh, why did I keep that as a negative? That's wrong. I must have gotten confused thinking that it was still negative, but we converted it to a positive number there. So that was the problem. From end. Yes, works first try. Too low. Index -1 out of range for... Okay, that's the wrong value. So we want to use the original value when we print that diagnostic. So, like, I need to remember the original index here. So let's call this one, like, index normalized or something. Normal index. So we're printing the original index there. So then go back. Here, right? It should say -3. -3 out of range for x. Cool. If we could extend the diagnostic to say, like, in parentheses, length is 2 or something like that, or we could even print out the actual vector. That might be useful. Why don't we do that? Because I already have the display trait for that, so yeah. Reference. Yeah, so here we'll just print values. Vector of option data values does not implement display. So this is the problem of using option value. If it was a vector of values, it would implement display trait, right? Oh, I know what I can do. The values comes from, it's been right. But if we put it into a vector, so if I use value ref and unwrap it, actually, or can't I do an optional binding vector? And then I can use the word vector, right? Oh, look how sneaky I am. Look at that. I hardly ever do this syntax in Rust. So in a match pattern, you can do a binding with the @ sign and you put a name in front, and then that name is like a local binding for that whole thing. And I happen to have a display trait implementation if you have the whole thing, and that should actually work. But that's super sneaky. I forgot what I did that for, though. I did it for signed integer indexing if it's out of range. So this one right here. Yeah, so index -3 out of range for x, and then actually we'll print out the vector there so we can see it. Should we like also do like a comma length equals? I don't see why not. The more we print, the better, right? Comma, length equals, and then we'll just put comma vector dot length. No, here I want values dot length. Okay, there. Now length equals 2. Look at that. With that if and that matches advanced, yes. Well, it's kind of like a side effect. Wrong reference. Yeah, so this is a side effect of this match. This is saying like if it matches as a side effect of actually this is also a side effect. Hey there, coding with strangers. How are you this evening / morning, depending on where you are in the world? I'm doing vector dereferencing right now. So here's a test of that. We can construct a vector now. We can reference it with an index, and we should print an error for that because we're using negative indices to count from the end instead of the beginning. And so this is just a test to make sure it's printing the right thing. It'll say index -3 is out of range for x, and I'm enhancing the diagnostic to print what the actual vector is and its length. So that's what I'm working on right at the moment. Oh, look at all those emotes. We in this mother lover. That's right. How was your stream, Coding with Strangers? If you don't have to go, and it's okay if you do, but if you don't have to go, then what were you working on? If you do have to go, then see you later. Thanks for the rate. So here's a positive test. Like this should return 42 because it's counting from the end, and it works. So those of you from Coding with Strangers who don't know what I'm doing, I'm making a tool that can parse data given a custom program that you can write. Working on figuring out code you broke and explaining why you do the things the hard way. Hey, that's what I do. I do that too. I figure out what I broke and I explain why I do things the hard way. Like all of this. This is doing it the hard way, right? I should be put in programmer jail for having 44 spaces of indentation there, shouldn't I? My sentence should be to refactor this, which I'm going to do, into at least one function, if not several. Yeah, this is unreadable. Indentation alone, right? But for other reasons. I don't even want to explain that code other than I was explaining this trickery that I'm doing here. When you have a match, this whole thing is a pattern that if this at runtime fits this pattern, then we execute this code, right? But you can do some cool things with patterns. You can have name binding inside of types in various places, and you can have them also outside the type if you use the @ sign. So inside the type, that name will match the value inside of the type. So that values will have a type of vector of option values, and it's a borrow because the outer one was a borrow, right? And then this @ basically assigns a name for that part of the match. So if the original thing was this value ref is a option of a value, then this gives you a value because it matched the sum part, right? Whereas this values matches the inside of the vector. If this whole thing matched, it was some vector, right? So I use that because in our diagnostic, we actually printed it out here. Use the outer binding because it handles the display trait, and use the inner one to get the length. So doing a lot of stuff in here in Rust that's unusual. having multiple names in a match is already unusual. And then like we're doing string interpolation here, and we're also doing overall formatting. So this is forming a string from a pattern, kind of like sprintf in C. And so you can interpolate if you can put a single word or a name, right? And if you can't, like if you have to do something dot length, you have to bring it out and then just put its placeholder there. So this is constructing a string out of 4 different values, 3 of which are interpolated in the string, 1 of which is brought out. And inside of this, it uses a macro from the log crate, which combined with the fact that I have a logger where we use simple logger crate, that allows it when I run this to actually have it printed out in a kind of a nice format. So we have like a timestamp and errors in red. And here's our diagnostic. And I didn't go into that, but we print where in the program the error happens. Line 1, 2, 3, 4, columns 13 to 26 would be here. So it says right here, we have an index out of range. Hey there, standard robot. Are you still a standard robot? Do you follow the 3 principles? Standard robot, do you know the 3 principles of robotics? It's not principles, it's 3 laws of robotics. Do you know the 3 laws of robotics, standard robot? You should know this, right? Being a robot. The 3 laws of robotics. First law, a robot may not injure a human being or through inaction allow a human being to come to harm. Second law, it must obey the orders given to it by human beings, except where it would conflict with the first law. Third law, a robot must protect its own existence as long as such protection does not conflict with the first or second law. Yes, as Isaac Asimov. Okay, let's run my tests to make sure. Hey, we're passing them all. Yay! Should I do this and get the fireworks? Come on, where are my fireworks? Where are my fireworks? Is that broken now? Can I do this and get the... There we go. I don't know why the double thumbs up isn't working. This should give you fireworks. Come on. Come on, give me fireworks. There it goes. There's the fireworks. All right, cool. So we can index vectors now. We can even index nested vectors, which is super sweet. We didn't even have a problem. That just worked first try. We break on that. Let's see if we get the same error. It cannot path into X. That's wrong. It should be cannot path into X0. Okay, there is a mistake then. We didn't add to path when we went into here, right? Yeah, so if we get into this, then where do I print it? When we evaluate the expression, right? So when we get into here, yeah, we add it to the path. So path plus equal format index. Why won't it let me do that? Because it's in a match. Yes. So yeah, I guess we're doing it in both places. Actually, there's 3 places we have to do it, right? Why isn't it like that? Oh. Is that what we had to do? Do we have to do plus equal with a reference? Yeah, we did. Isn't there like a way you can, like with a string, this path is a string, right? Isn't there a way you can just like append another string? Like extend? It's extend, right? Why is it as extend? Oh, that's for iterator. Okay, we don't want that. Never mind. Abort. So now the diagnostics should actually print that out. Because I wanted to say like cannot, where is it? Cannot path into x0. That's what it should say. There, cannot path into x0. Path means a dot and something else. So we're not allowing that yet because we only allow that for things we actually parse from bits. Shouldn't there be an ignored case for 4290? Well, that's not, that doesn't fit my grammar. So let me explain that. So in the grammar itself, what we're dereferencing there is called a reference. So let's find reference. It's here somewhere. Here's a reference. So a reference is a reference part, or it's a reference dot another reference part. So that's how we form that the dot chain, right? And then a reference part is either an identifier or it's a reference part and then brackets with an expression. So this is how we do the parentheses part, the indexing part, right? All of that gets bundled up into reference. Now, where we actually use the reference is in expressions. So we can use a reference by incrementing, decrementing, accumulating, assigning, or at some point we can just use it as is. Where would that be? Oh, in expression. Sorry, that's a statement. Expression. Yeah. So a reference can go into an expression. But how do I explain this? This is not a expression. That is not a reference. That's an expression. I'm not explaining it very well. Let's say I did something like this. The way it parses this is an expression, right? An expression is not a reference. But a reference is a kind of expression. They're not. Okay, I'm still not explaining it right. For this one to be the only syntax where this index 1 is allowed is that the left-hand side is a reference. But that is not a reference. That's a kind of expression called a vector expression. This thing right here. Right here. So that is the rule. That is the rule for that. That's the rule, and that's the actual, right? So it's a vector expression, but this is only allowed for a reference. An expression cannot be a reference. A reference can be an expression, though. So a reference can be an expression, but there's no rule that says an expression can be a reference. So it's not like it's not like a lot of other languages. They're not interchangeable. I think if I tried to make them interchangeable, it would become the grammar would run into ambiguities. So the workaround for that is you take the value of a vector expression and you store it in a local, and now you can reference the local. We could. I didn't test x1, but I could. Well, no, I actually did here. That would go into the index 1 and then index 0 of that. See, if I wanted to support something like that, what would I have to do? I would have to allow an expression to be dereferenced. So that would be a different kind of thing, right? In the grammar, it would actually be a reference would have to allow an expression in its grammar. I think that's probably a better way to explain it. That references, you can't put an expression in a reference. References are built from reference parts, which are built from identifiers only. So ultimately, a reference has to start with an identifier. It can't start with an expression. The identifier is a word, right? So X is an identifier. This is not an identifier, but if you take that and you assign it into X, now you can use X, the identifier, to build a reference. Okay, I've explained that one to death. I've beaten that horse to death over and over again. In fact, I beat that dead horse so much that the horse was raised as undead, so I could beat the undead horse even more. Yeah, exactly. So moving on. We can build vectors. We can operate on them. We can dereference them. But the next part is going to be the hard part. If I want to support something like this, and then later, like say data, like return, let's say we had a return data 0 or 2 or whatever. It doesn't matter what number I put there. That should be supported, because the whole point of having parts inside of loops is that these have what I call vector context. When we get to a data block, we know which count of the loop we're on, and then data becomes one part. Well, it becomes one component of GIF that is a vector, really a vector of components. It's a vector component, and each index is the component that was parsed for one loop. So if we did this loop 10 times, you'd have 10 indices in data, and each index would be a part. Technically named data, but you would have to get to it through an index. And that's the other kind of referencing that I wanted to support, was vector context referencing and vector context construction. So I think I'm just going to bite the bullet and write a test that does this, but a little bit simpler. Vector, we just do it in vector, right? And it's not going to be an erroneous test. This is totally going to work, right? So we need a loop here. I think what we'll do is I'll say for I equals 0, I is less than 2. Just keep it simple, right? Plus I. Parse as an unsigned integer X, 8 bits. And then we're going to return X1. So that should return the second byte. So let's put some bytes in here. 0x12, 34. So we should get back 34. Test vector indexing vector component. Component vector. So X becomes a vector component. In fact, I should be able to find it. So let X equal foo dot keyed children dot get X dot unwrap. So it's a component, right? And then we should be able to assert certain things about it. It should look like and behave like a vector. So I should be able to get its length. And well, hold on. Let's say that a component can be either a singular or a vector, right? And if it's a vector, it's going to be multidimensional. Actually, what if I just make it, it's always multi-dimensional, but if it has 0 dimensions, then it's a component. Okay, so then that means in the AST or in the data in value. No, not value. Component. Right. So fundamentally, I need a different type here. It would be, I don't know what to call it. Yeah, each of these would apply to one index. Actually, except for that. Hold on. So there's differences here, right? Maybe the error flag for a multi-dimensional component would be set if anything in the vector is an error, and each index would have its own flag. Actually, okay, then I'm thinking there should just be another part of a component, or another field of a component for the next dimension, right? And what would be the overall value of a multi-dimensional component? Would it even have a value? Actually, why can't it have a value? It could just be synthesized as a vector of the values of its children. Yeah, let's do that. So then we're just adding something. So this, if the component what? If the component was parsed in a vector context, these are the parts parsed in each iteration of that context. So it would be a, what's the name of it though? Iterations. And that's a vector of optional components. Yeah, because it could be none if in the loop we skipped it, right? And if we didn't skip it, it would be some component, and that component will be whether we parsed it. This is the thing that's sticky though. Like, this is just going to end up being a copy. I almost want to like bring that out. Yeah, but it'll every index will have its own children, will have its own origin, and it'll have its own value. It's just that the format will be the same for all of them, right? But maybe that's fine. We just end up copying the format for every index. Yeah, okay. I think I'm gonna go with this. So by default, there'll be no iterations. So this is vec new. New error also is empty. Formatted vec vec new. Okay, and just one warning, unused variable. Oh, right, because we never got it. So what can we assert about it? It should have an overall value of these two numbers, right? Yeah, exactly. So I can say assert that x's value is going to be some vector. And that vector has these values in it. The 2 bytes that we parsed out, right? What's wrong with that? Oh, we need more parentheses. More parentheses are needed. Okay, so that's its overall value. And we should just check to make sure all of these things are true. Like it doesn't have an error. So assert overall that foo is not in error, right? And also assert that X doesn't have an error flag. And then what else about the composite? It's I I guess we're checking all these things, right? Assert that it's UI to string. Actually, can I equate that with x.format? No, it's some UI. Well, if I do that, I have to turn it into a string, right? But I can I do like matches? If I do that, I have to turn this around, right? That still needs to be turned into a string. Yeah, okay, then never mind. We'll just do to string here. I was hoping that I could make it simpler, and that's just exert equal. Okay, so X is its format. Okay. Actually, while we're at it, why don't we just assert that foo's format is foo? Okay, and then what's past format? Keyed children. It shouldn't have any. Assert x dot key children dot is empty. Okay, it'll have an origin. And what do I care about the origin? It's offset and limit. Okay, so assert equal offset 0, right? So for origin dot unwrap dot offset. And it should have a 16 for its limit. Actually, no, it won't. Overall, it should have no limit. It's the indices, it's the things in the index itself. Whoops. To do that, we have to do an as ref. So this should actually be 0. Number of bits left in the, okay, actually then it is 16. Because there are only 16 bits to begin with. Yeah, okay, fine. And then it has a value. We already checked that. And it has, here's where it gets interesting. So it should have 2 iterations, right? X dot it dot iterations dot length. Okay, and then I want to repeat all of this for each iteration. That's iteration 1. So all these x's, x dots, will be x dot iterations 0 dot. Oh, we have to okay, yeah. What if I do like let x0 equal that dot as ref dot unwrap? Then it's a component, right? Then all of these becomes x0. And then I just repeat it for x1. x1. Iterations 1. Okay, and so what am I going to say? The value should just be like that should be the first value. And it's a UI. No children. The offset's 0. The limit is 8. No iterations. So that's easier said as it's assert that it's empty. So it has no second level. And then the second one has the second byte in it. Okay, and it starts at offset 8. Its limit is 8. It also has no iterations. So that's is empty. Okay, so this is going to utterly fail, isn't it? Let's see how it fails. Collision on X. Yeah, that's what I expected. So it collides the second time on the second loop. It sees that we already have an X. So it's a collision. So the first step towards implementing vector context would be to recognize we're in a loop. And if we are, then when we're parsing data, we're going to be allowing collision, but then inserting in the iterations of that part, right? I think that's what I want to do. And then we have to know, we have to have a stack of all of the nesting. In fact, I should probably make a special test for this. It doesn't need to be as long, but we should like test nested, test vector indexing component vector nested. So we have like a J or something. And then we should put one on the outside and one on the inside. And I don't really care about the value of foo at this point, right? Because the other test tests that. All that this really should do is we should have two children of foo, x and y, and x is one-dimensional and y is two-dimensional. Oh, and I can even make it more interesting. I can actually change the number of bits depending on if I equals 0. Or actually, I can compute this from I. So this could be I times 2. And we can just go from 1 to 2. So the number of bits parsed will depend on the outer loop. Because what I want to test is to make sure that, actually that doesn't really matter. What I really want to test is if I can collide in a different way. So I'll do it this way. Oh yeah, I know what I'll do. I'll say if I equals 0, then we have one kind of loop. In fact, to make it like really interesting, that should have been a else. It's trying to be helpful and indent it because it thought I needed to indent it, but I didn't actually want it to indent it at all. So if it's 0, then we do two more nibbles, let's say, and if it's otherwise, we'll just have it's actually, let's do it this way. We'll do 4 2-bit numbers. So the first time through, we'll have 1 byte followed by 2 nibbles. The second time we'll have a byte followed by 4 2-bit values. So I just need to, so there's 1, 2, 3, 4, 5, 6. We need 6 bytes total. And I want to mark them out so that I don't lose track. So that's an X. That's x0. And this will be, we need to pull these bits out separately, right? So 0001, 0010 is y0, y 0, 1, right? And then we have x1, and then here we're breaking it down even further, right? Two and three. Sort of to illustrate that, like, the inner dimension of y, if I flip it around, it's even more interesting because then we'll have to put nils into the first two. So yeah, why don't I turn this around? 4 and 2, and then that's 2 and 4. So then I'll just reverse these. Let's put something more interesting there, and actually that didn't do what I wanted. I kind of wanted it to do it the other way around. Okay, I know what I want to do. Put it back to the way it was just now. But what I'll do is I'll be really tricky. I'll be sneaky here. If J, let's actually, not in this one, but in the second one, because it doesn't really matter. I know what I can do. I can just move the J loop out. No, but I've tried to test too many things at once. One thing I wanted to test was that Y can be repeated and without a collision, as long as we have compatible, as long as we're in some kind of vector context. And they're not in the same, like, we can't do that because now it will collide, because by when we get to here, we'll go into the vector context and see that there's already an iteration there. So we can't do that. But it should allow this because you were only going down one path or the other. But I wanted to put some nils in there. So I guess it's just as simple as this. If J is greater than or equal to 2. Then I'll have some holes, right? And I can make that a 4 again, right? So then the first time through, I is 0. Yeah, so this is going to be 2 and 3. So then y00 and y01 will both be nil because we won't parse anything the first two loops. But then the next two loops will parse it, but the index will now be 2 and 3. So I want there to be nil. Okay, I think I'm happy with that. 34. Sure. I'm like looking at the bit patterns and I think I'm fine with that. Okay, yeah. Okay, so what do we want to say about this? There should be an X and there should be a Y. Do I care about X's overall value? Kinda do. X should be simple. It's just those 2 bytes. So actually that's still correct for X. It's just that Yeah, and I don't care about the other things. Let's just look at the values. I don't care about the format anymore. Don't care about that. Oh, wait a minute. What is the offset and bound going to be for X? For here, it was what? I think this overall origin offset limit actually doesn't make sense if we're in a vector context. It should be, the origin should be none. So we should, yeah, for vector context, the base should have no origin at all. So this should be that it is none. X origin is none. Because X could be from disparate parts of the bit stream, right? Because after the loop or before the loop, or inside the loop after and before X, we could have like thrown away some bits, right? So then overall X is like is collecting from different parts of the bit stream, so it doesn't make sense for it to have an origin, but the individual parts will. Okay, cool. I'm happy with that. Then down here it's the same thing. Do I even care about that at this point? I've already tested that aspect of it. I think this should only focus on the specific aspect that Y is multidimensional and has holes in it. So I really don't even care about X more than maybe just making sure it has the right value. And I don't care about this stuff. I don't care about its iterations. But I do care about Y's iterations. So that's what I'm going to test here. Let fix these up here. Okay, so Y should not have an error. It will have an unusually shaped vector, right? So it's a two-dimensional vector. The first, so there's two vectors inside of it. So let's pull this out to make it easier to do. The first inner vector looks like that, and then we have another vector inside of it. And this has to be a vec outer here, right? That goes away. Okay, then what's really weird about this one is it'd be nil, nil, 1, 2, right? Nil, nil, 1, 2. None, none, 1, 2. Or I guess like I can actually put the bits there. So we're just taking the bits off, putting them here. This selects the first 4, and then this selects the second 4. Okay, and in the second vector, there's 4 of them, but each one only has 2 of the bits. So 1, 2, 3, 4, and we're picking off these bits. So that one gets the first 2 bits. This one gets the second 2 bits. This is the third 2 bits. And then the fourth 2 bits. There we go. I don't really... Do I want to go into the iterations or just assert that the value overall is good? Oh, it did squash it down a little bit. If we get that overall value, I think I still will go into it. So there are 2 iterations of, so let's just replace the x dots make them y dots. Right. X0 becomes Y0, X1 becomes Y1. But these are multi-dimensional. So yeah, this is the value of Y0. Y0's value is this. It has a format. It does not have children. It does not have an origin yet. Y origin is none. It has 4 iterations. So here's where it nests. So I want this to be 4. 4 for Y0. And then I'm going to replace this with Y00. This is Y0 iteration 0. And that has the value none. Assert that Y00's value is none. It is a UI. It actually has an origin now. Finally, we have something with an origin. And a limit. So Y00's origin, here's where I need to count, right? 0, 1, 2, 0, 1. So it's at 8-bit offset 8 and 12. So the first one's at 8. It's 4 bits long. And then oh wait, that's Y02. Oh shoot. Okay. Well, let's just copy paste this. Y00. Okay, so for the first one, it has no origin, actually. Y00 has no origin because there are no bits for it. Same thing for this one. So this is a 1. This is a Y01. So first 2 iterations, no bits and no value. Right? Then iterations 2 and 3 actually have bits. They're at offsets 8 and 12. Limit of 4. And this we need to fix. Y02, Y03. Okay. Then we have Y1. And Y1 is like Y0. So let's copy from that. Copy all. Actually, why don't I just copy all of this? Copy and then paste over this. All right. And then from here on, all the Y0s become Y1s. I love multi-cursor. Makes this kind of insanity a little bit easier to tolerate. So now we have 4 iterations to Y1. So we have Y1, 0. Okay, and then these actually have bits. So... oh, I didn't do the value. Okay, I need to fix that. This is one of its values, right? That's Y01. No, Y02. This one equal that for its value. Yep, and then Y03's value is 10, right? 10. Okay. And did I check X? Or maybe I'm not caring about X so much. Yeah, I didn't go to X as children, but it should be 12 and 34. I'm not going to care about that. We're really only caring about the multidimensional one at this point. So we're going to get 2 bits at a time out of this one. And these are wrong, so let's fix that. These are the inner ones for the second iteration. Like that. Okay, and then these are the bit we're gonna have. Everyone has bits. You have bits. You have bits. Okay. Y10 value. Y11 value. So it's 0, 0, 0, 1, 0 again. And then 1, 0, right? 1, 2, and 1, 3 is 1, 0. Okay, now the offsets. So they all have offsets and limits. Okay, what's the offset of the first one? 0, 1, 2, so 3 times 8 is 24, right? Because this is 4 bytes, right? So it's a 20-bit 24. So 24 for 2 bits. And then it's 26 for 2 bits. And then it's 28 for 2 bits. And then it's 30 for 2 bits. All right. Completely disintegrated those 4 bytes in a very strange composition. So it's that X had 2 bytes in it, spanning the even numbered bytes, right? Or the odd numbered bytes, however you want to call it. And then Y picked out bits from the other half, and they're sort of in order because they happen to be adjacent. The inner dimension is adjacent, but the outer is not. So, and the inner one has 2 holes in it because of this if. Oh, another test we could do is that if we put a 6 there and we put an if it's less than or equal to 4, we won't create holes because it will actually never reach the statement. Yeah, like that, right? So we won't, even though it goes to 6, we basically won't parse past the 4th index. So we'll never actually do anything for indices 4 and 5. Whereas this one does something for the first index is not 0, it's 2. So we'll expect 2 holes. But we won't expect 2 nuns at past this. It's still going to be only 4 iterations. The only thing I'm not testing is a hole in the middle somewhere. To actually make a hole after, we'd have to actually assign it to, or we would have to parse it as a nil thing. Okay, I'm good with this. So this is gonna fail. I have a lot of work to do though. So we're basically going to have a collision on X on both tests, I think. Yeah, collision on Y, collision on X, right? And that's the first thing to solve. Okay, so how am I going to do this? First, we have to have a loop variable in the context, right? Context. So context itself. So if you're watching now, then you're in the epic moment where Raimu is actually Introducing vector context into his tool, something that's never before been done with a tool. Probably, maybe. I was looking at a component. Oh, I didn't know we did that. That's cool. Yeah, I forgot we did that. This is the parsing vector context. Well, that's going to be the name, vector, right? Or it should be like iteration. So I guess I can use the terms parsing vector context. This is the parsing vector context. When executing statements inside of loops, we allow collisions and use these indices to construct subcomponents following. We use these indices to construct subcomponents using part names indexed. Okay, this is hard to word. This is the parsing vector context. When executing statements inside of loops, we allow collisions. It's when executing parse statements inside of loops, we allow collisions and use these indices to use these indicates to find where parsed components should be stored within the composite. There we go. That's what I want to say. Good night, Garchwalls. You're missing the best part, but everyone's got to sleep, right? So this is going to be the iterations, because I wanted it to mirror data component has iterations. So this is like gonna be sort of a stack, right? What am I doing here? I don't know. I want to go to context. How did I end up here? I don't know. Iterations, it's going to be a stack, right? So I think I can just use a vector because we're always just going to push onto the end or pop off of the end, right? A vector of... It doesn't matter what types the outer uses. It's going to use U-size indices. You have a question for me. Do you think as a newish programmer it's okay to be using ChatGPT for a lot of things? I use ChatGPT now. Do you think it's better to try working things alone, just use it when you're stuck? It depends on what you're asking ChatGPT to do. So I think that if you're asking ChatGPT to write code for you, then you're not going to learn how to code. You're only learning how to ask other people to code for you. So if you don't need to learn how to code and you're okay having something else code for you, that's fine. But if you want to go from being a newish programmer to an experienced programmer, you don't want ChatGPT or even a human. You don't want the code to be written for you, but you can still use ChatGPT to answer questions like, is there a library in Rust that can handle complex values in math, or quaternions, or how do I invert a matrix? Because those things aren't doing the programming for you. They're giving you the background that you need to like either find the right library or how to use a library or what the mathematical background is. And that's, I'm finding that ChatGPT works really well as the front end to a search engine. So if I need to find something, or I need like a description of how something works, like I use ChatGPT as like as a teacher. I say, hey ChatGPT, teach me how a linked list works, and I think that's fine. Just ask GPT to rename variables for you. You're using it incorrectly, so you're using it to generate code for you. It's the equivalent of going to your teacher and saying, give me the answer. Teacher's going to say, the whole point of learning is so that you can come up with the answer. So an appropriate question to a teacher would be, teach me how to find the answer on my own. So give me the background knowledge, give me the understanding of the problem so that I can construct the answer to the problem. So, and that's fine to ask ChatGPT. I've been asking them all the time, and it's very useful, because otherwise I'd be trying to like guess the right search terms for Google, and I hate that. I'd rather just ask a natural English question and have it like interpret the context of what I'm asking, and then collect together the information and give me if not the correct answer, at least enough background that I can look it up myself. Currently, you're feeding it code block and asking it to fix it for me. Describing how it did it is okay, because that's just replace ChatGPT with my computer science teacher. If you're asking your computer science teacher to fix your code for you and describe how it's done, that's fine, because the describing how it's done is the teaching part. But if you were to say asking it to fix your code for you, that's like saying, give me the answer and don't explain how you got it. Feel like you're cheating a little bit? No, you're not cheating, as long as what you're getting from it is the description of how it's done. If that's of value. So it's not of value if you're doing a quiz, because quizzes are all about getting the answer. And if you're just telling it, give me the answer, the description isn't valuable. But if the point is to learn how it got to the answer, then I think it's fine. Just be aware that ChatGPT can get it wrong. I was asking it the other day how to get the rank from an enum, and it gave me an answer, and then I asked it, well, how can you do it automatically? And then it gave me an answer, here's how you do it, and it gave me the manual way. And I'm like, okay, it's not understanding the context enough. So you have to like get a second. We have to like use your common sense and maybe make sure that it gave you an answer that's right. Yeah, don't assume that it's right. Assume that it's probably right, but you want to verify. Just like if you had a friend who never admits that they're wrong, right? You ask them a question they can't answer, they're going to give you an answer as if they know it, but it's probably going to be BS. Now, it might be completely off, but more likely it's going to be like maybe it knows somewhat the answer, but it's filling in bad details. You always assume it's wrong. Like I was saying before, I use it as a front end to a search engine, so I don't actually need the full correct answer, but I would like some leads. Like if it tells me what Rust crates to look at, that's a good thing. So for example, I asked it, how am I going to, what's a good Rust library for doing a parser generator? And it told me nom. And I looked at nom and I said, this doesn't work because nom doesn't work with lexers. It's like kind of built-in lexer. So I just told it, give me a new answer, and it said, try Lollerpop. And I looked at Lollerpop and I'm like, that's perfect. So it got it right on the second answer. And if it continued to tell me like nom, then I probably would have went to nom, and then I would have asked ChatGPT, is there something like nom but done in a different way in Rust? And then it maybe would have eventually given me the answer. So yeah, use ChatGPT as a teacher who BS's sometimes. Because it doesn't seem like ChatGPT is really that willing to tell you how certain it is. It'll tell you an answer, and it'll say, yes, this is the answer, and it's like confidence level 36%, and it doesn't tell you that. Okay, iterations is a vector of sizes. So just defining that, we get errors because a new context, we need to actually have a default iterations in our context. So we're just going to make that new. And same thing for new with part. That alone will make it compile, but it still won't work because we're actually not using it. In fact, we're going to get a warning that we're not using it. Look at that. It's so helpful. It's never used. Okay, so there are two places where we need to use it. We need to maintain it by adding and removing it, and we do that in the loop stuff. Then we're going to actually use it when we're doing the dereference mutable. And we also need to form composite values on exit, I guess, right? Or I guess when we get out of the loop. In fact, every time we pop from iterations, we should go in and we should form the no. It should be at the very end of the part, right? Because we can, like the test is showing, we can have independent loops, right? So once we leave this loop, we could have had another loop context for the same thing. And that is actually allowed to fill in the other one's holes. I also have to remember that. Or is it? If I had if I deleted I didn't mean to do that. If I deleted all of this and just did that, we're going to have two Y's, but is that a collision? They're in independent loops. I'm going to say that yes, that's a collision because we'll close Y when we leave this outer loop, and then we would go in again. We'll see the same slot numbers and we'll say it's a collision unless the slot is empty. And it can't be empty with a hole. It has to be truly extending it. Yeah, all right. I feel like I should make a test for that, but maybe not now. Maybe to do later. Test that we can extend vector components, but not fill its holes. I hope that I remember what that means later. Stream subset. We don't need that. Don't need these files open anymore. Where was I? It was a component, right? Yeah, so I can close everything else for now. Close others to the right. Okay, and close this one. Close to the. There's no close to the left. What? Okay, close others. Reopen components. There we go. All right, so let's do the filling of iterations first. So that's done in statements, right? Okay. Execute for statement. Right. So here's our loop for a for loop. At the beginning, what we should do is push a 0 into the current. Yeah, we should just add a 0. So self.iterations push 0, right? And then outside the loop, well, that does returns. Okay, then I actually want that before we, yeah, right here. Push that, and then this will pop it. And then in the loop, we're going to increment the one on the end. And where do we do that? I guess when we fall through to the next execute expression condition, that's the loop condition. Then we execute the statement next. Okay, so it's right here then. Self.iterations.last dot expect somehow didn't set up loop vector context. So that plus equal 1. Can I not do that? Assigned and oh, self is not mutable? It is mutable. Oh, do I have to do last mute? Yes, I do have to do last mute. Okay. So it's basically looking at the last thing in the iterations vector, and there has to be a last, otherwise we didn't set it up right, and then we're adding 1 to it. Okay. So this nests, right? If we execute a statement and the statement is another for loop, we'll end up pushing another 0 at the end, which is exactly what we want. But we have two kinds of loop. We also have while loop, so I need to do the same thing there. So there it's similar, right? Except we have these returns. Okay, so I need to have the inner again. So really it's like this. And that's not public. That's inner. And then the way this works is we say let result return scope equals execute while statement inner. All the things, and then we end in return scope. But before that, we do self.iterations push a 0. Before return scope is the self iterations pop. Like that. And then here, yeah, here's where I don't actually want to continue. We want to fall out of the match so that I can do dereference self dot iterations dot last mute dot expect, and I'll put that message in a second, but plus equal 1. I want to copy that from the for inner. This thing somehow didn't set up vector loop context. Loop vector context. Okay. So now we've built up the indices. Now whenever we so we get to these like parse statements right here. And these end up doing this stuff, registering a component, right? And it does it by doing this find vacant child entry. Yes. Non-part child entry? What does that do? Oh, that's for locals, right? Yeah, so it's for this one that I care about. So locals are exempt from the loop context. They're completely immune because they can be reassigned. It's the parts that are not, right? Right. So here, this is going to have special code in here. Consider fully adding the component rather than just locating a vacant entry. Yeah, actually, we might need to do that now. Find all references. So it's actually called from two places, the local statement and Actually, why is that using local? Shouldn't this be doing non... Yeah, we're gonna end up colliding. Okay. Oh, because local can't redeclare a local. Well, why not? Why not? Can't I just use this? That returns an option. What was the point for that? That it might return a none, and then we would do an insert? I forget. I didn't search for the right thing there. There we go. Oh, I guess the cat's hungry. We must feed the cat. You need some food? You need food? Meow? We must feed the kitty. We have fed the kitty. Take this sweater thing off too. All right. All right, so yeah, we only call it from there. What do we do if it's none? We don't do anything. Wait, if it's marked as local, it can be referenced in the current text, but will be removed from the key children. Okay, that's true, but at least at first. Wait, isn't this a problem that if it's occupied and it's already a local, we return none? But then the value, the part is wrong. That's a problem. I need to fix that. That's a bug. Because it does nothing, which means it discards the part that we worked so hard to parse. It's okay for an ignore, right? But for a look ahead, I actually need that value. Yeah, I need to fix that. I don't want to fix it right this moment though. Do I? Yeah, I don't want to fix it right this moment. So I'll make a test for this. It should be under local, right? Or maybe it's parse or part. I should have had a test for like, oh yeah, here it is. No, that's X and Y. I can fix this, right? So I can just redefine it and it should tell me that the value is 0, 1, 0 now. Because it ignores the first X, but the second X, it should return that. So this is going to fail now. Oh, but I can't build this, right? Oh no, it does build. Yeah, so it's the wrong number. Okay, should I fix it then? Since I have a test that focuses it up. Need to let the kitty out now. You need to go out. Go on. Get. If I don't let the cat out of the office after she feeds, then she bothers me. If I'm streaming, she like wants my attention. We've been going for 4 hours, 29 minutes, and 29 seconds. Oh, we don't need locals. It was part. Yeah, this thing. This is actually test, ignore, and reuse local. So two purposes. Yes. We can use the value of the local, but it's not actually stored. Got it. Okay. So then I can try to fix this then. Really, this should be called find non-part child entry, and then we should be able to just return any kind of hash map entry, right? This should just be result yes, because we sometimes want to return an occupied entry, but when do we ever return none? Okay, it is okay, we never do. So this should just always return a hash map entry of that type. Okay, so then this would be entry. Actually, this should just be entry up here, right? And match entry. Oh, actually, no, I have to do it the other way, right? Because that consumes the entry. I should just repeat it. Entry at, and then I actually don't care about this part. And it's okay entry. This part here is also entry. As long as I put entry in front there. Okay, fixed it. So now it could be vacant or occupied. If it's occupied, we make sure that it has to be declared local. If it's not local, then it's then it's actually a named parsed and a goal of parsing it, and then that's a collision. Cool. So we're gonna rename this. It's find non-part child entry. Follow the references, because that broke this, right? So then it's not that it's some entry or none. It's that it's a hash map vacant entry. Or is it, I forget how, I should just let it fill parts, right? It's like hash map entry vacant and like, how does this work again? It's just vacant, right? Vacant. Entry vacant. Like that. Okay, I did it. Okay, so the other alternative is hash map entry occupied. Okay, and for that, we don't need to do the insert, and it's dereference entry equals part, just replacing the entry, right? That is actually, maybe I don't need to dereference. That's occupied entry. Do I just do, I don't do equals, right? Or do I do it and I just mark it as mutable? I forget how this works. Entry dot get mute, and then dereference it. It has to be mutable. Yeah, there we go. So this should say something like, it gets mutable access to the entry, gets a mutable reference to the value in the entry. Yes. Okay, cool. So that should now pass my test. Cool. All right, I fixed it. And I should probably also test, like something like this should also still work. Yeah, okay, cool. Fixed the bug. So I'm back to the loop stuff. So that was at the end, right? Where did I put? Was it in vector? Yes, I put it here. Okay. This still fails because of collision, so that's where I was going to go next, right? That in statement for find vacant child entry, here's where it has to like be able to, it has to allow occupied if it's in vector context. So actually, you know what that means is before doing this entry thing, we have to resolve the vector context thing. Okay, so then we're gonna do let mutable parent equal, we start with self.composite, and that needs to be mutable, reference to composite. And then we say for iteration in self dot Organ Mike, how are you and your 2 raiders? I'm doing like arcane stuff with my parsing tool. Actually, with the unit test, I can kind of explain it maybe in a way that makes sense. Oh yeah, I hope you had a good stream. Thank you for the raid. I'm working on a parser tool. So my parser tool has its own language that you describe how to parse stuff. And actually, the interesting one that we're doing right now is here. Right. So it's like if you have these bytes, 12 hex and 34 hex, and we describe how to parse it, we say that this is a foo, and the foo has 2 bytes in it. And we should be able to like take the second one and make that the value of foo. Then we expect the value of foo to be 34 hex, right? The second byte. But there's also inside, we made each byte, we gave it a name. And so that means 2 things, that we should be able to index x as if it was a vector because x was declared inside a loop. And the other thing is when we get x out, its overall value is the whole vector, and also it should have 2 parts inside of it, one with the 12 and one with the 34. And those 2 parts should remember where in the bit stream it got those 2 bytes. So that's what I'm working on now, what I call vector parsing context. This is a statement in my language that says for the next 8 bits, parse an unsigned integer and name it x. So right now, when I run the test, it's going to say there's a collision on x because it'll loop, it'll assign the first byte to x, and then it'll loop back, and then it'll say, I can't assign to x, x already exists. So I'm adding in the concept of that if you're inside of a loop, it keeps a loop variable, and then it'll first locate x, and then within x, it forms a vector and of 2 slots, and it picks the slot based off of what loop count it's in. So it's no longer a collision. I am having a cute night. How are you, Easy Zero Mesh? Although I'm not sure what cute means. I guess my kitty came in and demanded food, and then ate, and then demanded to be let out again, and she's cute. All right, so if you have any questions, let me know. In a big picture sense, what I'm doing is for fun in Rust, I am making a tool similar to Wireshark. So that's a tool that you can have it collect traffic from your network card, from the internet, anything coming into your computer, and it starts off looking like just raw bytes, and the tool will interpret it as what they are, what they mean. Each one's a packet, and within a packet, there are different fields. And so inside the tool, it has knowledge about how to translate the bytes into to assign meaning to the parts. And in their user interface, you can click on a packet and you can click on a part of a packet and it shows you where in the bytes it is. So I'm doing the same kind of thing, and like a more holistic example would be parsing an image file. It would first, as a string, look ahead the next 24 bits, and if it's GIF, then parse it as a GIF file. And a GIF file has a header, it has a trailer, and then a logical screen, and then there's a bunch of data blocks, and it goes until the look ahead of the next byte is 3B. And so again, like tying into what I'm doing right now, I can already do standalone parts like the header, logical screen, trailer. Those are really straightforward. It's just parse 24 bits as a string, and do it again. Make sure they match certain patterns, right? That's all good. But it's when we're in this loop that this data, we need to make data a vector, and then each loop populates a different slot of vector. So that's what I'm working on right now with this unit test, which is a more simple version of that, where we're just looping twice and we're making sure we don't collide on X. And we can also pick out a slot of X if we want. And that X overall is a vector. And then it has these iterations of X that have the individual bytes and they remember where they were in the bit stream. So we're in finding the slot for X in this case, right? It used to just look and see if it exists as a entry in the keyed children dictionary. And if it did, we just say it's an error. We can't do that anymore. We have to first go to the composite structure and loop through these iterations, right? And I'm going to want to borrow that, not pull it out. So what we'll do is we're going to look, we're going to match basically this. In fact, I'm probably going to want to do name to string first, right? Actually, no, that's not right. If self-iterations is not empty, we want to do this first and populate the root entry. And then we're going into the iteration vector inside of it. Yes. So yeah, yeah, that means we're not returning a hash map vacant entry at all, right? I have to do this. We have to fully add the component, and because if we're going into this component, right? An iteration of the component, like it's not a hash map anymore. Key children, it's a hash map, but here it's we'll just end up having a reference to a component in the end, right? Actually, it'll be an optional reference to the component. No, but we're filling in something, and we're gonna. Do we even need to return anything out of this? Find all references. So this just does an insert, right? New unformatted with value actual. This, what does this do? It inserts a new one. So I could just pass this to, and we could just call it fill vacant child entry, right? Yeah, and then this one it just populates it with part. Entry, insert part, entry. Yeah, okay. Because if we return an error, then does it matter if we populate the entry or not? If we return an error, we won't populate it. It's only if we don't return an error that we'll populate it. Okay, then I've convinced myself. This should be called add child. Okay, and then it does not need to return anything. but we do want to indicate if it succeeded or not, and as a result, which is kind of a weird type, but it's just a flag, whether it succeeded or not. And we use the formal type result to remember that if it didn't populate it, it actually is an error. And we actually don't even want to do that, right? We want the caller to, we want to actually return a reason string, right? And then have the caller. Actually, we're in context. Why am I using error then? Shouldn't I be doing self on error? I should. Should be doing self on error format. So we get the full context of it. Okay, anyway, actually if I do that, do I need to return that? We're already setting that flag. I think we do because then we want to start parsing, right? Okay, so then yeah, that's fine then. So match this. No. It's this name, right? This name is only used the first time. Subsequent times we're looking in the iteration. Okay, so then we move this to the front, right? Yes. And we move this to the end. And this is only an error if, okay. Right. Let entry equal that. Semicolon, and then we say if self.iterations empty is empty, then let, I shouldn't have deleted it. It should, because I want to put what I had before. How about I undo and put it in my clipboard and then redo. Put it in the clipboard, then redo. There we go. If let vacant entry equals entry. No, not even a if let, it's let. Else. It's a collision, right? Then we're doing, we need to pass in the part, don't we? Or, yeah, part. That is a data component. Right. And that's entry equals part. Or entry dot insert part, right? If it's vacant. Okay. If it's not empty, then it could be either vacant or occupied. If it's vacant, we populate it. And if it's occupied, we well, either way we want a mutable reference. Okay, so then we have an else. Right. So delete that, put a bracket there. Okay. So then we don't need to return anything, right? So this we will collide if we're not in a vector context. We always collide. Otherwise, we want to match on that entry. And we're going to end up with the parent in the end, right? Entry dot, no, entry. Okay, if it's occupied, let's do the vacant first. The vacant one is easier. The vacant one is just entry dot insert no, not part. We want a shell. We want a data component new unformatted. No, new formatted. New formatted takes a bit stream though, but I can pass it a none. So it gets, actually the add child, I need to know what the format is, right? So format. The origin's none though. And that returns me a mutable reference, right? So that's exactly what I want. So take off that semicolon. Okay, for an occupied entry, we're going to end up doing entry.getMute, right? And that should return me the parent, which is a mutable component, and this needs to be mutable. Okay, then we loop through the iterations to find the slots. Actually, the last one has to be unoccupied. So I think that means that I want to do all of them but the end. So how do we take the last off? We can do skip, but that skips the beginning, right? That's like that. If I turn it into iter and then how do you like take all but the last? I guess if I knew the length. Hey there, KC18. Oh, you've been here. You just want to know what I'm working on. I hope you were here for the intro because I think I've explained what I've been doing a bunch of times, and I'm super focused on this, and I really don't want to take the time to explain it again. So hopefully you don't need the explanation. For iteration, okay, so how do I want to handle this? We're going to populate entries all the way down, except for the last one. We're either going to use or populate all the way down until the outermost. So I think I do want to know let depth equals self iterations dot length. Then we're doing for this in iter take depth -1. And what we're doing is kind of the matching on well, actually it's just if parent dot iterations that's right, we're not allowing it to fill holes, right? Or am I? No, I'm not allowing it to fill holes. Actually, I could, because iterations is optional component, and even if a component has a nil value, we could allow a hole to be filled, because it'll be no component at all. Okay, then we're fine. We just want to see if there's an occupied entry there. So if iteration is less than or less than iterations dot length, then it's a collision. Well, then it has to be none, and we're going to replace it. Else we're going to possibly add holes and populate the last entry. Okay, so then yeah, this is complicated. This is an error here. This is a collision error. No, it's not a collision error. It's let some child Actually, it would be if parent dot iterations index. I guess I can do a get. Oh, shoot. I could have used that all along. Right? Because get for a vector returns a reference to it depending on its type. If it's a position, returns a reference to the element. None if out of bounds, right? None if out of bounds. So I could have just said let it be in range. If it's in range, right? Okay, then if let some actually then aren't I doing a match? I'm doing a match on this. Iteration. This should be a star. What's wrong with that? Don't need to do that. Okay, so there are actually two values this could be, right? Because that itself is an option. So there could be some entry, and I don't care what it is. That would be a collision. This one would be a hole, and this one would be fill a hole. So let's put in the collision case first. That's this. Collision. Oh, we should have a path here while we're doing it, right? So I guess it would be right here. Let mute path equal name dot to string. And then when we take an iteration out, path plus equal format iteration. And then this is collision on path. Okay, so if it's sum, then it's just a hole, right? And then I can just get the whole thing. Actually, this should be get mute because we're going to basically put it back into parent. Because that's a mutable reference to a component. We just have to put a component in there. So slot child, I guess. It's an optional reference to right. So then I can just say some child. Because that's a mutable option. That's a mutable option. That's what I want though. Oh, what do I want here? Definitely don't want that. I think I wanted the child inside of here. Because now I can assign it. I can actually construct one. I can say child equal this one. New formatted. And why didn't it like that? Oh, sum. Okay. If it's none, then we have to actually fill the holes first, right? Actually, no, we don't have to fill the holes. We just have to extend the original parent. So parent dot iterations. Like, how do you extend it out? extend. Like, I want to like, okay, I'm gonna look it up. Rust, extend a vector. Was it just push in a loop, I guess? I mean, I guess I could do that. Fine, I'll just say this while parent dot iterations dot length is less than iteration. Well, +1. Then iterations push none. Basically putting the holes in there, right? And then we're going to push, so parent iterations push some new unformatted data component. Okay, and then I need a reference back to that. Does push give it to me? It does not. So I need to actually get it back out. So yeah, let's have it just say parent equals. So then this should just say child. Oh, actually that won't work, will it? It would be right, where this inserts it and then we're going to end up getting it back out here. Okay, so then this should be parent. If we get to this part, parent equals parent.iterations.getMute iteration. This just makes sure that that it either we populate it or we fill in holes and then push one at the end. And this has to do a expect. So expect we failed to fill the fill a component iteration. Okay, why is that not good? Yes. Oh, I need to do as ref. No, it's actually 2 expects, isn't it? Because this one indexes, and then the next one should unwrap it. Well, as mute expect. This is the actual one I was hoping. We failed to fill component iteration. This is we failed to make room for. There. All right. So this expectation should be satisfied by this. Like if we got a none, we should fill it, right? This expect should be that we actually put something in there. So it's either sum or we did a sum there. Either way, that's what that expectation is. Can I learn coding by myself, or do I have to go to university? Hey there, Digital Human Stream. I say that, yes, you can learn coding by yourself. You don't have to go to a university. You can learn Rust too. You can get started there. Although I wouldn't learn this language first. I'd learn something simpler like JavaScript first. What if I want to code an AI or build robots? That's a good question. And I'm trying to remember what... Is it Mindstorm? Is that it? Yeah. I would start with something like Lego Mindstorm. Because those are programmable robots. Can I learn from Twitch? I don't know. You'd have to find someone who's doing robotics programming on Twitch. And I've actually never seen a stream like that. But you certainly don't need university. They got stuff you can find where you can program robots, and the code is extremely simple. Yeah. You're 25. I don't think age is relevant. It doesn't matter how old you are. You could be 80. You could be 5. Build a keyboard without a caps lock key first. I got one right here. No caps lock key. But I see what you're saying, Phil Powers. Are we all shouting now? Is that how you guys keep me awake? You just shout? Not buying a Lego set to learn coding. Okay. Suit yourself, I guess. Or just map caps to control. Yeah, there we go. If you're not already an expert by 10 years old, you don't stand a chance. I don't know if I believe that. I'm not the expert in building robots, that's for sure. I've never actually built one. And I've never actually made an AI, so I'm not an expert on building robots or AI. Okay, so... You like watching? Okay, well, couple suggestions. Please slow down in the chat and don't use all caps. Using caps quite frequently to change keyboard layout. Aw, thank you, DigiHuman. Well, I hope you have fun here. DigiHuman, you sound like you would really enjoy this stream. He's not going now, but you should watch the Primogen. I think you'd really like the Primogen. It was broken, yeah. I get you. I have this vibe. I have this vibe that you'd really like the Primogen, but he's not streaming right now, but he streams all the time. You watch that too? Yeah, definitely follow him. I think you'd get a kick out of it. I just get that sense that like that's more of a stream for you. You watch Twitch a lot? Cool. Your account was created 5 days ago, though. So what? You've been watching Twitch for a lot in the last 5 days? Okay. Welcome to Twitch, Monka S. This is your streaming account. Okay. How many streams have you done? Your old account was called something else. Okay. We don't trust DigiHuman. I don't know. I think everyone's different. Some people like to type in all caps until you help fix their caps lock key. Everyone's different. Oh, you like the chat thing? Here's someone else for you to watch, but you have to be careful about this one, okay? Oh, I have to wait 16 seconds before I can give another shout out? Okay, I'll wait 16 seconds and then I'll hit enter. Right now the only chat is you, DigiHuman stream. Oh, well, there's KC18, but I think KC18 is just joking. Okay, can I give a shout out now? Okay. Be careful about this one, DigiHuman stream. But CM Griffin, if you're nice to him in his stream, he streams all the time too. He made this chat overlay, so if you like the chat, go watch his channel. He'll teach you something about web dev, designing web pages and stuff like that. But he's a lot more strict than we are. Yeah, see, I'm telling you about all the cool streamers, and they're all different philosophies and rules. So Primogen is more about entertainment, in my opinion. Not that he's a bad streamer, but the focus is more on having like fun and doing memes. So I think that would really vibe with you. CM Griffin would be more like serious. So you should be nice and behave yourself there. Here, it depends on the mood I'm in. Sometimes I'm tolerant, sometimes I'm not. Just remember, wherever you go on Twitch, you need to understand the rules and try to follow them. And be careful about the all caps. All right? It's in most streams, more than 50% of the time, that'll get you kicked out. So got to be careful with that one. Yeah, be nice. Be nice, we'll all be happy, okay? So, this is super complex code and I don't trust it. But it should find the right place, right? I just need to make sure I actually do something at the end. Right. That was the whole point of this, was we leave the last for doing this right here. Actually, that's, oh, for goodness sake. So I need to actually, I don't want to do the take depth -1 because I actually do need to look up the last one, but I need to handle it differently. This is also a collision if it's the last depth, if it's the last one, right? And if it's the last one here, we don't make a new formatted, we actually use part. That's the difference here. Rust seems a lot like Python. I think it's a lot like C, but with like new stuff added in. Like from other languages, this some and none, I think, wasn't that from OCaml or something like that? To me, Rust is like C with a whole bunch of other languages smashed into it. That's why I like streaming this, because it's challenging. If it was in Python, then we wouldn't have any semicolons, right? Or was that yeah. Isn't that one of those rules in Python? You can't have semicolons? Rust breaks your head every time you see it, very dense stuff. That I like challenges, you know? I'm also starting to lose my voice, but it comes with the territory. Okay, yeah, we need the depth because we need to know when we've reached the depth. So actually what I want to do is enumerate. And we need to record the step number. Okay. So that we call this one last step, I think. This only goes in here if iterations is not empty, right? So this should be safe. If I do last step, is that -1? Okay, so here's the trick. If step equals last step, we're doing something differently. In this case, it's a collision. Okay, in here though, we're not, it goes into here, right? If step equals last step, then it's part. Else it's a new formatted component. And that looks indecipherable, completely indecipherable. So I'm going to change this around. I'm going to say this is the child, and we're saying let child equal that. The only thing I'm worried about is it's going to think that we moved part out and we're in a loop, so this might be a problem, right? The only other option is I move it out of this loop. Gosh, I hope that Rust is smart enough. I just need to fix this error, right? So yeah, hold on, what the heck is this? Pipelate composite arguments. I didn't think we had to do this. Oh no, yeah, we do. That is an argument now. So that goes there, and we don't need entry. We don't have an entry anymore. There. What's the problem? It takes 3 arguments. We need a format. Okay. Didn't we say it was unformatted? I know what to do. We won't accept a format. We'll take the format from the part. So let the format equal part.format. It's optional though. Yeah, it's optional, so yeah, we're just making a copy of it, right? And that goes into, oh shoot. Where does that go? That goes into sum. So I guess I need a new constructor. Hey there, Zany. How are you? First time chatter? Who hasn't been here before? I guess I could just have a new. I mean, it's kind of like new one formatted with no value. Okay. I'll just have a new. It'll be, oh, actually, how about we do new with format? Format will be optional. So we just put that there. And that's format. There we go. Easy. Value is none. Okay, so then I can go back and I can just say new with format, right? Not here. New right here. Yep, I think that'll work. Yes, welcome. Just give you guys a taste of what I'm working on, since this is a 40-line microscope into a huge thing. I'm trying to make sort of my own version of something like Wireshark, only I'm doing it for fun and I'm doing it in Rust. What Wireshark does is it like you feed it in network packets and it parses it all. It figures out what the packets mean, and when you click on a packet, it'll like give you like what are the pieces of the packet, and then you can click on a piece and it shows you where that is in the bytes, right? Kind of like a smart hex editor. And the way mine is designed is in this custom language, you define how to parse the file that you give it. So if it was a image file, you would use a format like this, where you use a program like this, where you say, I'm going to give you an image. So look at the first 24 bits as a string, and if it's GIF, parse it as that. And that has a header, it has a trailer, it has data blocks and all that stuff. And these are kind of like structures and their functions. There's structures in that like a GIF or GIF file starts with a header and ends with a trailer, but it's also a function because we parse it in order and we handle things like loops and conditionals. The loop means that data is going to have like more than one instance. So it'll be like a list of datas. Whereas header and trailer is just one of it. And the if lets us like stop parsing or generate an error, whatever we want to do, right? So at the moment, I'm working on this unit test where we want to parse as this foo format, this sort of made up format, these 2 bytes, 12 hex, 34 hex. So this 18 or 16 bits total, right? And we say to parse a foo, then you're going to loop twice and you're going to parse as an unsigned integer, 8 bits, call it x. So because x is in a loop, x will be a vector and it'll have 2 slots in it because we loop twice, right? I is 0, I is 1. There's going to be 2 slots. The overall value for foo will be the second slot of x. So we expect x to get back the 34 hex. I mean, the foo will have 34 hex, right? X will be, since it's in a loop, it will end up being a vector with both bytes in it. But if we go into x's iterations, we'll have 12 for the first one and 34 for the second one. And it'll remember where the offset into the bit stream of where those 2 iterations were, and then how many bits total. So that's what I call vector context, that we're parsing x within the context of a loop. So x forms a vector rather than being a scalar. Hey there, Ramy. Ramy, we're in the middle of the most complex part of my parser, the vector context. Did you just come in right in the middle of that explanation, or were you lurking long enough for me to have started before you got here? You heard it? Nice. So Ramy, does that make sense, the vector context? You got most of it? With these unit tests, they're also like supposed to be documentation. So like this is explaining that when you use this format with these bytes, we expect that you're going to get 34 back because it's asking for the second byte. That sort of tells you that x is a vector, and it's a vector because it's in a loop, right? So the hardest part of this is detecting collisions. If I did that, we get a collision because we have the same name in the same iteration of the same loop. Bad news, right? So we expect a collision there. We also have to handle nested loops like this. So this is a non-colliding multi-dimensional parsing loop. Like basically like a compromise between as simple as I can make it, but complex enough to test a few things. Like we'll have holes in y because we have this if j is greater than or equal to 2. So if it's j is 0 or 1, we don't parse anything. So y is in a vector context. It's in a 2-dimensional vector context, I and j, right? So in iteration 0 of the outer loop and iterations 0 and 1 of the inner loop, we don't have a y. But then 2 and 3, we do have a y. And then the second iteration of I, we actually loop 6 times, and the first 4 times we fill in a y, and the second 2 we don't. And I wanted to show that iteration 0, there's 2 holes, 0 and 1. And in iteration 1, we don't put holes in the end because we actually never parse a y after iteration 3. And this is mixed in with an x just to show that like y is disjoint now. Like the bits for y are not adjacent to each other anymore. So it's super complex, but yet simple enough to test. Yeah. Okay, so this is going to be this, right? Shoot. New with format. I think I'm going to have problems with things being moved out in a minute. And I'm going to cry sad crocodile tears. Okay, I've got 6 errors in statement, though. Because this needs an actual part, right? Right, so it's comma part. We don't have an in, so this should just be if okay. So actually turning this around, it should just be if it's an error. right? Done. Okay. Same thing here, right? We're going to take this and put it there and then say if it's an error, then return an error. 3 errors. Okay, here's where I was gonna cry sad crocodile tears. Because we have something that doesn't live long enough because it's dropped while being borrowed still. Crap. Entry does not live long enough. It's because I'm storing back in the parent, right? What is the problem here? Entry dropped while still being borrowed. Is it like into mute? Is that how it works? Yes. I remember that. I remembered that. Into mute is the form that consumes self so that it doesn't need to outlive the borrow. The borrow makes it through the entry and out the other side. And it doesn't need to be mutable anymore. Okay, that we've solved one thing. Now, this other one is because format's moved, right? Moved. So we've moved on line 89. Yes, so I think I just have to clone these everywhere. Just, when in doubt, clone it out. Because we don't actually know when we can consume the original format, right? It's borrowed value, borrowed after the, so where did it get moved? Down here. Clone it out, right? Okay, and this, we said it doesn't need to be mutable. Okay, and we're down to 1 error. It's been moved in a previous iteration. Yeah, I was afraid of this. There's a trick I can do for this one. We can take part and we can put it into an option that's mutable. And that's all in, so at the beginning of this loop, we can do that. Let mutable part equal some part. So it's kind of like something we can take out of. And then when we go down here to part, we can say part take. I just have to make it mutable. I did. Okay, and then what's the other error? So this should be unwrap. Take it and unwrap it. Hey, look, we only have warnings. Why do I have a context here? Well, I don't remember why I have a oh, because we used to return a borrow. We're not returning a borrow anymore, so I don't need that anymore. Wow, okay. I'm amazed and impressed and somewhat horrified that this actually compiled. This monstrosity. Wow. Okay. Let's see if it runs. Yeah, it failed. It failed. I didn't expect it to pass the first time. Let's see how far we get. X nil is not indexable. Oh, actually, that got pretty far. So it didn't collide, right? It's just that the dereference didn't work because I never actually formed the X composites value. Need a new Rust compiler flag, yell at bad code that doesn't compile if you have some shenanigans going on. Yeah, this is cool. So the question is like X itself doesn't actually have a value, right? But we could give it a value every time we parse a slot of X. We could reconstruct X's overall value. Or we could wait until that is done, and then we can descend into the iterations of X and copy a value out. So I'm inclined to do the following. So whenever we index into a component that has iterations, we can descend into it like that. The other thing is to make the other, that'll get past this first one, right? That'll actually make it execute, but it won't let us pass this test. To pass this test, then on exiting from foo, we need to have an overall value for x, which is its composite structure boiled down to a value. Need a new Rust compiler flag, yell at bad code that doesn't complain if you have some shenanigans going on. Isn't that just its default behavior if you have some shenanigans going on? Or do you mean like if it detects that you're doing crazy stuff like I did? Con here, right? Like when you have these weird match patterns. So I did that so that I could do assignment and actually replace the slot or replace what's in the slot. So the slot is there, it's some slot, and the slot is empty, and we fill the slot. That's shenanigans enough, right? What's the other shenanigans I did? Well, I mean, cloning isn't shenanigans. That's just saying I'm okay with wasting memory. This is sort of shenanigans because these expects, the only way to get rid of them would be to do the getting the mutable reference like in the loop, which I guess we could do. And then fall out. It would just be I guess what we do is we do a fold. Instead of an enumerate with a for loop, we do a fold. And the thing that falls out would be the parent, right? Oh wait, no, this is every iteration. Actually, that is what it is, because when we fall out of the for loop, actually we don't even need it, so it doesn't even need to be a fold. It just needs, well, we would just ignore what comes out at the end. We don't need that at the end, right? It's actually discarded. That last assignment at the last loop, it just falls out of scope. We never use it. Gonna head out, KC18. Okay, thanks for being here. Was glad to answer your questions. Sorry I can't answer all the questions. Sometimes I miss them and I feel bad later. Sometimes I can't answer them because I don't know how. But I'm happy whenever I can. Okay, so the referencing thing, let's do first. Had 2 hectic days at work. Rami, I've had 2 hectic weeks at work. Okay, the fire extinguishing system going off, that beats me. I've just had a lot of meetings and a lot of Slack messages. So one day last week, I left to go to lunch. By the time I got back, I had 48 Slack messages waiting for me. I took a screenshot and sent it to my boss and said, look what happens when I leave for lunch and when I come back. Look what I have. Look what is there to meet me when I come back. You know how you have the Slack conversations and there's a little red circle with a number in it? I had like 7 of them, and one of them was 9+. Because at that point, Slack just says, I don't need to count this anymore. You just have a lot of messages in this thread. So it's like 9 plus some large number. That makes Slack notifications need to take up all your paid time off. Fortunately, it wasn't just a DM with me only. It was like a group DM, and so it's the people within the group talking to each other. So I didn't have to follow up on all of them, but man, whenever I was at lunch and I heard the ping, 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 and I'm like, I hope they're not waiting for me to answer. Where are you? We're on fire. We need you. We need you to answer now. Okay, I think we're parsing correctly. We just need to retrieve values out. So that's in dereference. So I have that in a reference, right? Dereference, here we go. Right, which is itself an ugly thing. Okay. Right, I remember this. We have to know whether or not we've descended into a value. Yes. And this is not true anymore. If we have indices, we either extract a value or we go into an iteration. And actually, we prefer the iteration because that has the original values. Okay, so let's rewrite this. If we have indices, descend into descend into a component what? Into a component iteration. If there is one, or extract a value, or okay, if we have an indice, if we have indices, one, if the component in the path has iterations, descend into them. Actually, I guess I don't need to number these. Star them, I guess. Wrap that text. That's not what I actually wanted it to do, but if I do that, it should fix it, right? If the component in the path has iteratinos, descend into them. Otherwise, expect a vector value and extract from it. So that's what these matches do. Match some vector, and if it's not, then it's not indexable. So here's the thing, right? We should check. So we're only going to do this if there's no iterations. Okay, but if we've already... Hold on. Yeah, we have a check up here, right? If we've extracted a value, it's an error to not be at the end of the path. So yeah, so this is if the part doesn't have iterations. So that's what we're going to say, right? If I don't know. I just thought of something. We could descend iterations and then have more indices after the last one, and then we do want to descend into the part, right? So I actually want to do this and put this in the loop, don't I? No, I don't want to do that. This value should go inside of this, right? Hold on. I need to think about this, but I also need to take a quick break. I'll be right back. Enjoy the chair stream. Okay, I'm back, but I have a hungry cat with me who must feast. All right. Epic chair stream, huh? The chair is talking. No, the cat followed me in. She's like, I want to eat again. If we have indices, if the component is a path in the path has iterations descend into them. Otherwise, it keeps wanting to fold that on save. Okay, whatever. I won't fold it then, fine. I think it's because it's like right one character past or something. I think I know what I want to do. First, not pursed. First, descend into the components iterations, if any. Next, expect a vector value and index into it. Right. So that means this is not true. It will start as none, and part descends into the composite, because part is just a mutable. It's an immutable reference to a component, right? So this should work. So yeah, let me copy paste that comment, the original, out, because this is going to be none at first. Right. So we're following the indices. We're first going to say if part dot iterations is not empty. Actually, if it is empty, we can do the match, right? And that's one huge thing that I should probably put into another function. Else we're going to do something else. Okay. Yeah, this is crazy indentation. This means I really need to refactor this. Okay, anyway. It's when we get to this part, if it's empty, then if value ref is none, then we need to initialize it as the current part's value, then match it, because it has to be a vector at that point, and then we're indexing into that vector, and we're getting we're updating value ref at that point, and part stays the same. Yeah. This has to be sum. So this also needs to be sum part value. So that's an option, right? Option value. Yeah, okay. No problem. Sum. It'll never be none. So can I just do as ref unwrap? Yeah, that works, right? Actually, this should be expect. Because this makes sure it's something, right? So if we didn't do that correctly, then the panic should say something like lost our value chain. Lost our value. Yeah, lost our value. Panic! It'll panic with a special message that will be a reminder about what we were trying to do at the time. So it's not that we expect to lose our value, it's that I guess I could phrase it differently. I should say we expect shouldn't lose our value. Should not lose our value. There we go. So the panic will say, panic should not lose our value. And then I'm like, oh yeah, we lost our value because it was it was none, right? We lost it. Don't panic. Don't panic. Panic, don't panic. All right. Okay, and we get all the way down here, right? And then if we still have an extracted value, copy the value at the end of the path. So yeah, this should be an unwrap or else. But if it is something, don't I want to doubly unwrap it? No, I think the problem is this has to be unwrapped again. Hold on. This value ref, right? It's got an extra option around it. So this like has to be sum. No? Oh, wait, no. That already is the outer. This could be a none. Okay, that's okay. It's this clone that's a problem. So it's gonna get the wrong. It's too many options. Option. No. Yeah, that's wrong. Yeah, this. Hold on. If we don't get out, if there is no indices. It's just, oh, right. It's just the parts value. Yeah, I think this actually just goes outside as well. Does that mean I should just... Oh no, I needed this to be inside this loop. But if it's still none out in the outside of the loop, then we do that. There we go. But that's not the real problem, right? What's the real problem? I think the type is still wrong for value. Yeah, that's not right. Oh, right. This has to do an unwrap, an expect. Same kind of expect as before, right? Actually, then what I want to do is it should be value ref, right? It should be value let value ref equal value ref unwrap or else. Actually, I guess I can do unwrap or. I don't need a function. Just unwrap or some part.value. We didn't like that. Oh, it just needs to be as ref. It expected a reference to an option data. It got an option. Oh, there's no sum there. That's wrong. There we go. I fixed it. Option. Sounds like the correct English says to buffalo. No, now we fixed it. All the types are better. The problem, Rami, is that a value, like one kind of value, is nil, and also we might not know it's nil yet. So none means we don't even know if it's nil or a value. If it's some, then it could be some nil, which is none, or it could be some non-nil value. So the options mean different things. Like the outer one means, have we found it yet? And the inner one means, does it actually have a value or not? And I'm getting my, so I might actually back out of that. The alternative to using option value is to actually make nil a possible value, to distinguish between a nil value and lack of a value. Because I actually want them to be distinctly different things. The lack of a value and nil are different states. So none's basically Schrodinger's cat, Rust edition. It's just saying that it's basically there's two possibilities. It's just either no value or it's some value of some type. But that type could itself be another option. So you can have a none, a some none, and a some some. And you can nest that as you nest that until you basically go insane. And then that's where you stop. Okay, all of this to say that we descend into the parts value hierarchy if we have no iterations. Otherwise, we want to first descend into the components iterations. Okay, I need to let the cat out before she does bad things. Kitty, I'm going to put you outside. But first, you're going to look into the camera. Okay, the kitty has lost her collar somewhere. She is collarless. And she doesn't want to purr right now because she hates me. Hi, kitty. I wonder where her collar went. Kitty lost her collar. Either that or Mrs. Ramu took it. Gonna clean the house? Are you gonna keep me on in the background? Should I motivate you with like success stories of the code? Hey, it's working, Raimi. I hope your cleaning is going well. Gonna put some music on. Oh, okay. I'm not too offended. Only a little bit offended. Not too much. Okay, so if we have iterations, we want to descend into it. So it's similar code to this, right? We should evaluate it as a usize, right? So I need this stuff. Maybe not all of it. Let's grab this much of it and paste it in here and then cry. Okay, so let the index, oh, we shouldn't really need that, right? So evaluate the expression, match it. If it's some unsigned integer, then we're forming that path. The index is a size. So here we go. If it's part.iterations length, if it's greater than or equal to that, then it's out of range. If it's signed, then it's part iterations length, counting from the end. No, counting from the beginning. Here's where it's counting from the end. Okay, and I need to actually have the vector. Actually, here, we're just going to say what the length is. Because the vector is a complex type, so that's just going to be that. All right, and then this is totally not formatting correctly because it's like you've indented so much that you've now run afoul of the indentation police. Expect a call from them. For now, we're just not going to do anything. Okay, so yeah, if we get something, then we just cannot be used as an index error. Okay, so that reduces down to an index, and then yeah, this isn't just part equals borrow as immutable, right? Isn't part part's immutable reference, so it's just part dot iterations in get index. Well, yeah, isn't it just get index expect? Didn't expect index should be valid for part valid as a index should be valid for part iterations. Semicolon. Iterations. Oh, it's an optional component. Right. If we hit a hole, what do we do? What do we do if we hit a hole? That should be an error, right? No, no, it shouldn't be an error. It can be nil. Nil is what the value will produce, right? But there better not be another index after that. Yeah, I think we'll just reduce it to value. We'll reduce it to nil. So if let iteration equal this. And actually, I don't want to move out of it, right? Actually, no, get returns a reference, so we can expect. So that should give me, I don't need to do this borrow, actually. Then this else, so this would be part equals iteration, right? It's a type. Why can't I do that? It's still an option? Wait. I thought get... Oh. That's the validity of it. And then, yeah, this should be a sum. Right. Else, that means we found a hole. So we reduce that to, we actually set this value ref is what we do. Where is it? It's in this if part. Then we do this. So we say value ref is sum none. Value ref is sum none. Value ref equals sum none. Can it not be sum none? Or it's a, oh, it's a borrow. Okay. Then that's a problem. Crap. So I have to actually make it value equals. But the problem is that it's never read because we end up reassigning it out here, right? Oh, you know what? I have an idea. We'll just panic. We'll throw an error if this is ever something. If value dot is sum. And I should do it here, right? If value is none, then we get a value from it. Yes. Is none. Do that. Okay, and then that means we allow the value to be set early, but if we get up to here, then this is an error. This stuff. So cannot index cannot index the path, basically. I think that'll work. Hold on a second. Good time, I think, right? All right, I'm back. So 0 warning, 0 errors. Should I just go for it? One should never code like this. No, one should never write code like this. This is monstrous. But hey, let's just go for it. I remember doing a similar monstrosity for the C++ version. And I guess I should have expected this to happen. Okay, it actually got to the end, but it got something, it got a none for, oh, because I didn't do that part. Okay, that's good. So it got further. It got a value, it got the component X, and it wasn't an error, it just didn't have a value, right? Because that was the last thing I hadn't done. So it actually got the correct value for foo. That succeeded, which is awesome. That meant that this dereference works. The problem is that the overall X doesn't have a value, and it should have a, we need to like basically extract out the values of every component at every level and like fit them into place. Hold on, I don't think actually we should do that. Because what if like, what if X is itself a vector? Like, actually, if at any point, yeah, we could have it could be ambiguous, actually. So what's the easiest way to describe an ambiguity here? It would be that we have a nested loop and like this, like with a J instead of an I. Okay. But then actually no, it'll still work. You'll just have vectors inside of vectors, and you won't remember, it won't track whether or not the innermost vector is came from a part or not. Actually, but then yeah, we're losing the fact that it came from a part at all, and we're just getting the value. Yeah, so this should be still fine, right? Yeah, so we're good. We're good. We're good. So the point I want to do it is that at the end of a component, we should go through all its children, and if it has iterations, we should extract a vector out of it. And we need to do that recursively. So that means we need to have we need to have a function that turns a component into a vector. And no, it turns a component into a value. And if that component has iterations, then that value is a vector of the values of each iteration. Yeah, that's what I want to do. If it doesn't have iterations, the value, it's intrinsic. The value that it has is just copied, it's cloned out. Okay, so I know what to do. That is in context in ingest component. Right. In fact, we can do it after we finalize locals, right? Because finalize locals removes from key children all the locals. So this would be finalize components. And actually this doesn't need to be public, does it? Neither does this. Finalize components. Hey there, Liquid Draft, how are you doing? Mute self. It does a similar thing, only it's going to be doing for child in self dot composite dot keyed children dot values mute. Yes. Yeah, so this will build it up from bottom up, right? Yeah, okay. Then this is not too hard. It's just that we say if child dot iterations is not empty, then child dot value equals some data value vector, and then those values are formed by iterating. So child dot iterations dot iter dot map iteration. And this is where the recursion has, no, actually, no, it's built from the bottom up, right? So no, that's not true. We can have a nested loop. And so we have to dig all the way down. So each level of the iteration needs to compute a value. So this this thing itself, I need to call a function that's recursive at this point, I think. So it would be yeah, it would just be iteration extract value. Oh, that can be none. Okay, so then map, right? Map, yes. Or if I'm doing a double map, don't I want to just do a oh, how do we want to do this? That's a vector of options. So this is an option. They're two different maps. This is a map for an iterator. This is a map for an option. So they're, even though they're both the word map, they mean different things. So this should mean like iteration again. Although it's gonna just look weird. So here it's a component. So I want to do iteration dot like extract component, right? And that's the recursive part. To extract, let's extract value. So what that does is if it has its own iterations, it'll do this recursively. Actually, then part of this should go into this extract value, right? This is what goes into that. This is iteration extract value. Actually, no, all of this is. The outer is special though, right? Because if iterations is empty, then it gets its return value from the return statement. That of when it was parsed. It will have an assigned value. Yeah, okay, so we'll just keep it like this then. So I just need to define this then, right? On component, implement component, x public function extract value self gives us an option value. Make sure that this compiles with the to-do there. Nope, because that needs to be data value, which is not right here. Expected vector of options of values found a map. Oh, we need to collect. Yeah, this outer one needs to be collected. Value of vector of options data cannot be built from option value. There's a double option in there. Went through chat history, could not find what are you building about. Well, I probably explained this about 10 times in the last 6 hours, but I don't mind explaining it an 11th time. Yeah, look, there's my keyboard. That was last year's project. So this stream is all about doing fun things in Rust, and I get to define what fun means because it's my stream. Basically, for fun in Rust, I'm making something like Wireshark, only it's going to work with any kind of data because I get to define the format of whatever I wanted to parse using my own language. So if I wanted it to parse a GIF file, I would use something like this. This is actually extraneous. I was trying to illustrate that like I could also add JPEG in here if I wanted, but it's a programmable, it's a general purpose programmable decoder. So if you feed it this format, it will be able to understand GIF files and break them apart. So this is both a structure and a function because you parse it in order like you'd execute statements of a function, but everything you parse is a part or a component of the overall file or stream, right? So a GIF starts with a header, ends with a trailer, and you have data blocks. Inside of a loop, that means data is actually a vector, and every time you go through the loop, you're populating one slot of the data vector. So I'm working on the part right now that handles the loop context. Like if it's parsing data in a loop, then it knows to make that a vector, and at the end, assemble the vector with all of the values of the individual slots. Yeah, I built an AST and a symbol table. So that is on my terminology thing. So I wrote this originally in C++ and I'm porting it to Rust. Originally in C++, I just had one formatting library that combined Elixir and the parser, but I've since split it out so that I can have completely abstracted away dependency-free token type and AST types. And this being the compiler, already done. Although I'm making small tweaks here and there. I'm working on the ingestion part. It uses the AST to break down the data. So I can show you what the token type looks like. This is between the Elixir and the parser. So we have a special one for counting lines. We have a special one for errors. We have all the reserved words, identifiers, numbers, symbols, literal strings, right? Now, if I go back a step to what the parser implementation is, it's using logos. Logos. Makes ridiculously fast parsers, right? Or lexers. Logos. There we go. It's a Rust crate for making a lexer. It's pretty cool because you use attribute macros for things like your regular expression patterns, your white space, defining your tokens, regular expressions for your symbols that have attached data to them. And then I basically map that back to the abstract form with this one-to-one mapping. Mostly one-to-one. Some of them are mapped together, like lexer error can have unterminated string, and it could also have bad string or illegal token. You did a similar thing once in your compiler course using C for custom language? Yeah, cool. So in your compiler course, was this the book you used? The Dragon book? Because that's the one I used. I don't know what classes these days in compilers use, but this back in like the mid 90s when I was learning this stuff, it was Bison and Flex. And that the Dragon book was like the gospel. So that's one end. The other end is the parser generator, and I'm using Lollipop for that. So you make a recipe for Lollipop that is in our build.rs. This process root discovers this Lollipop file, and it's kind of like GNU Bison. It uses all these Bacchus-Nor form rules to generate a parser state machine. So you describe all of your grammar of the language using these rules. So overall, this format that I'm making, well, it's a format list, right? Each of these is a format. They can refer to each other by identifier, but fundamentally the compiler only sees these as separate formats, and a format is a sequence of statements. So that's what we see in the grammar. Formats is just a hash map from the format's name to, where is it? The format's name is the identifier to the actual statements that are inside it, right? We take that and we put it into a hash map here with these rules. I follow this form where you have an empty rule, and then you have a chain rule, which is recursive. So building on a previous formats, you start at nothing, and then you add the next one by inserting the next one, and then reducing back to to be used for the next step. And then this is a special catching lexer errors rule. Yeah, and the format again, mostly it's in the statements, and the statements are what did I do here? A statements is just a vector of statement, and the statement wraps us. We use these special markers to record where in the lexer locations the statement is, so that when we print out error messages, we can say what line and column numbers the statement that was bad can be found in. And the statements are like when we're parsing or we're ignoring or looking ahead bits, and then all the conditional logic and other kinds of statements. And then we have all the stuff. Lollipop doesn't support operator precedence or order, so you're forced to do tiered grammar rules. So I had to have 12 different levels of expression. The lowest associative, lowest precedence is outermost, and then the innermost is the highest order operator precedence. So the binary operators and the literals. And the escape hatch, which is the parentheses rules, is right here. So it escapes back to level 11. So that builds the AST, which looks like this. So we have a hash map of these, of formats keyed by the name, and the statements is a span statement, and the statement can be parse something, conditional logic, different kinds of loops, that kind of thing. Parse statement is like you have some arguments, you have a optional bound, the format to parse it with, what you're doing with it, how to interpret it, and its name. And we can either parse something as a part of a composite, we could ignore the bits, or we could be doing a look ahead. And I use the look ahead for here, for like when we're parsing GIF, we want to parse 8 bits as an unsigned integer called next, but not actually keep that part. So it's a look ahead rule. We rewind the bit stream 8 bits when we're done, and then next becomes a local variable. So data is actually a part, so that gets stored and consumes bits. And this is only just to know when to break out of that loop. Because a trailer is a 3B. When we get to trailer, that has to be 3B. Hopefully that's enough explaining. More than enough explaining, right? Wow, it's 1:30 in the morning. I should probably get some sleep. I want to get this vector stuff working though. Right, and I was almost done. Follow the error, right? So it just needs to know the type, right? Vector of options of values cannot be built for option. All right, I have a double option in here somewhere. I'm not sure exactly where. An iterator of optional components. Oh, don't I need to like flatten this? Yeah, because we could extract the value and the value might be none, or there might be none to begin with. I think I want to do a flat map. Why can I not map that? Cannot move. Oh, yeah, sure, as ref. There we go. I did it. Flat map. Flat map because the iteration itself might be a whole, or it might not be a whole and just have a nil value. Either way, we're going to flatten it, and only if it is something do we want to extract a value from it. Wait a minute. I actually don't know if that's right. It's an option here because it could be a whole. Oh, right, because after we extract a value, that value might itself be nil. That's why. Okay, so then this extract value, I need to fill this in. So this should be the easy part. I just need to maybe repeat this, a part of that. So if self iteration, so child becomes self, then we return this. Else we're going to return self.value.asRef.clone. And hopefully I got that type right. Oh, I'd have to do what is it? A clone here, not asref. There we go. I did it. So if the component has iterations, we're returning a vector of all the values of its iterations as a vector. Otherwise, we're taking its value, whether it's something or nothing. And then that goes into this one, which is a little bit different in that the outermost one uses its keyed children. Yeah, okay, I think this will work. So let's test it. Still failing. We got further though. We got, oh, the vectors are empty. They don't have the numbers in them. So that, what does that tell me? That each iteration didn't actually keep a value, but it should have, though. It should have a value in it. So I kind of want to set a breakpoint there. to see why we didn't actually collect values. So it's this extract value that I care about, right? Right there. Let's go debug. Use compilers, principles, and techniques. Yeah, use the same book. The 1985 one, right? The first edition? Where does it say the first edition? Where's the year on it? I'm just gonna assume that it's copyright 1985. It's a really bad photo of it. It's all blurry. Huh. It's probably inside the book, it says, right? Bad pictures. Yeah, I think it's the same book. I think you and I read the same book. Okay, so self iterations is not okay. So the value is some value, and there's an 18 in it. Is that what I expect? Yeah, 1, 2 hex is 18. So then how is this actually working? We should step over that. Oh, I got this backwards. This is backwards. If it's empty, we do that. Otherwise, we do that. Right? Okay, cool. I think that was it. So back to testing we go. Oh boy, we passed. Okay, cool. So that means we got a vector out and we passed all of the conditions. Everything is good. Now the true test is, can we do a nested loop? And we cannot. So we panicked at, we failed to make room for a component iteration. Okay, we panicked right there. So I suppose we should I don't know, debug. Hit that. Okay, so the name is X. Format's an unsigned integer. Path is X0. Parent has one iteration. It's what? Oh, right. It's a. Oh, right. What's iteration? Is it 0? It's 0. So why would that crash? Is it okay? Let me just hit go again. Okay, the X was okay. Now it's on to the Y. Now it's on to the Y2. So I should be looking at parent. So yeah, as long as this. Oh, it didn't make enough room. It didn't make enough room. It should be 3. It should have made room for the third one. Okay, so that's the problem, right? Let me look at this code and see why. So it it went into here. Maybe it's this one. The +1 is wrong. It should push one more in, right? So if iteration is so let's put a breakpoint there and start over. Debug. You're back, standard robot. Welcome back. I'm just debugging here. Okay, here we go. So parent iterations is 0. It's empty. right? And iteration is 2. We wanted to actually push 2 things in there. So 1 is, yeah, it's that +1 is wrong. It shouldn't be a +1. This should be while the length is less than the iteration number, because we're pushing an extra 1 down here. Okay, so let's just hope that it just works now. Nope, it didn't work. And we got foo has an error collision on Y0 on line 8. 1, 2, 3, 4, 5, 6, 7. So here, collision on Y0. We're supposed to allow that to collide because it's not the last step, right? So I'm not allowing it to collide. Let's find out why. Context. Okay. So it's not the last step, right? Last step is length minus, maybe it's that -1 again. Let's put breakpoints on the collision points and not on the non-collision points. Just see where it's colliding. Debug. Okay, we collided with iteration 0, right? And what's last step is 1 and we're on step 0. Why is last step 1? Last step is iterations -1. Oh, wait. This didn't even look at last step. Oh, yeah. This should have an if step equals last step collide. Otherwise, we don't actually make a new thing. We just step into it. Well, actually, it should have done that. So this should just be if the step is the last step, then it's an error. So this just needs to be put into that. All right, run one more time. We failed. Oh, we got further though. It's just that this line we got no value out. Should have gotten a 52 for foo value. Actually, we shouldn't get a 52. That's an old thing, right? I don't care about the value of foo anymore. Delete. That was copy paste error. Okay, what now? The composites, this huge structure is wrong. This one right here, this huge structure is, okay, I need to let the dog out. I'll be right back. You know, I thought it was like 11:30 and it's actually 1:30. And I've been going for 6.5 hours. I must be having fun. So, it's going to be hard to read, but there's a vector with none, none, some, some. That looks good, but the values are 1 and 2. That's correct. The next level is some vector 0, 1, 0, 2. That's that. That's what we expect. What did we actually get? We got some vector with some 1 and 2. Okay, so the holes are missing. That's the problem. At the first level, these 2 holes are missing. So definitely need to put those holes in there. Why didn't the holes get put in there? it should be that we get a none, and it should go into here and add a hole. So I kind of want to see that happen. Oh, wait. No, that is happening. I think I know what it is then. It's when it's assembling the final return value all the way out. So delete that breakpoint. I think we're actually good. We're on the way out. We're building. It's the finalization, right? It's the finalize components. There's a bug here, and now I need to let the dog back in. Okay. So, iterations, right? Iterate the iterations. I think it's the flat map. I think this is actually wrong. Flattens nested structure. I think it's getting rid of my nuns. I think the flat map is doing something I didn't expect. So if it is so this is going to be some none, right? Then if it's not a flat map, it goes in here. It'll be a none. So this will be a problem because as ref, it won't map anything. It'll stay as a none, right? Shouldn't this be like unwrap or unwrap or none? So this type is a reference to an optional component. So if it's some component, we're going to have we're going to map that component to extract its value, which gives us back an optional value, which is fine. Okay, but if the component is not, if it's a none, yeah, I think this needs to be like a unwrap or. And then this internal thing. So then it's a as ref map. So this is like unwrap or do I just do flatten here? It's going to just tell me that's a flat map, right? He wants me to do a filter map. But that's exactly what I don't want to do. I don't want to do a filter map. I think that's what's happening now. It's dropping the nuns. So then, isn't this just unwrap or none? Well, it's this inner one, right? Or is it just and then? Or just and? Dot and dot. Isn't it just this dot that? Hold on. Get rid of that bracket. Why can't I do that? Because it might not be anything. Yeah, okay. Um, fuck. Back up. This is what happens at 2 in the morning. Let me actually go here and verify that I see that it has holes in it. All right. So here, debug. I want to see that it's actually collapsing the holes by mistake. So, I actually don't need that one, right? Child iterations. It only has 2. That's fine. It's when we iterate into this. Oh, actually, that's actually not here, is it? It's when we go into no, it's here. Right. Extend extract value, actually. Here's what I wanted to go to. Go to there. So self.iterations. Yeah, see, there are the holes. Some, none, some, right? So I think it's just it's returning 2 things because collect is wrong. It's like dropping the nuns. It's just that I can't see what it is. Okay, let go back to here. I actually want to see it in the debugger, so let values equal this there. And yeah, that's exactly where I want the breakpoint to be. Run. Oh, not run. I want to debug. And I don't care about that breakpoint anymore. Yeah, see? It only gave me two values when there are 4 iterations. There should be the same number. So this is just wrong here. Collapse these 2. Okay. And probably the outer one is also bad, right? Because the other one has a flat map as well. That's in, I can't even remember where this is now. It's too late at night. Show references. Yeah, it's over here. This also has a flat map, so it's probably also wrong. So I just need to fix this. I don't want it to stop. I don't want it to filter out the nuns. So we can't use flat. Flat map is probably filtering, right? Flat map. So if I go to flat map and I see how it's implemented, it probably like, it does this inner next, right? I actually don't even understand that code. It's too obscure to me. Okay, so what was the key combo for bookmark again? Control Alt L and okay, Control Alt K. Right, and then Control K. Okay, then go between these two, right? Actually, let's just put a K there. And a K there, and toggle, toggle. Okay. So we're extracting a value. The vector of optional components. So we iterate. It's an iterator of optional components. We want to map those optional components. So iteration is an optional component to as ref gets the borrow on the inside so that we can map and we can have a borrowed component and extract a value, right? And that gives us an optional value from a non-optional component. So we have an option at that point. I think I want to do flatten. But it doesn't like me doing that. It wants me to do a filter map, which is not right. I guess flatten's not the right thing to do here. Yeah. What does flatten actually do? That's as an iterator, right? Flatten. We were just looking at this, right? That I can't decipher. Or is this what we were looking at before? Flatten compat. I don't know what I'm looking at. Should just look at the manual. Dude, manual. Here we go. Flatten. Iterator flatten. Creates an iterator that flattens nested structures. Useful in iterators or an iterator of things that can be turned into iterators. See, this is not what I want. I want to turn an option into an option. So isn't that map flatten? It's like option flatten, right? Yeah. So I think I want to do flatten inside. I want to flatten at this point, right? Map flatten. Try replacing map with and then and remove the plat. Okay. Is that it? I think that is it. Okay, so then in the other spot. Oh, well, let's just run this to make sure. Because we're all set up to look at that, right? There we go. We got, okay, we can't look at it for some reason. Invalid name, but it has the same cardinality as iterations, which is good. The original had the nuns in it. This one we can't see it because the debugger is weird like that sometimes. But okay, then that's good. So then I want the same thing on here. So it's map and then. All right. Hopefully this does it. So format vector run test. And we got further. Okay. 87. Okay, cool. So then the overall structure of Y is correct, but it didn't get Y0 correct. Oh, did I want to support that? Actually, I don't think I do. Or do I? If I reference Y0 in while parsing, what will it do? It'll descend, it'll use the component structure, right? So this is expecting a value for Y0, but it doesn't actually make sense to have a value there. So maybe I don't care because Y overall has a Y0 would be this thing there, which is what we're looking for. Yeah, I think I will relax my test and not expect individual iterations to have values in them. Well, except that I do kind of want to see these individual value. Will those still individual values still be there? I think they will be. This is an aggregate, and it's not the topmost aggregate. Do I care? If I care, actually, it's not too hard, I think. Let's put a bookmark here. Go to here. Extract value. Okay, so finalize components, right? Um, yeah, so when we extract a value from the iteration, I think this should be mutable on self. And what it should do is it should return a clone, but it should also store it on itself if we get into here, because these values it should store on itself. Okay, so that's what I'm going to do. Self dot value equals some. Well, actually, why can't I just say that values? Well, value equals this. Let value equal that. And then this is value.clone. And then value. Because that's a problem. It's mutable behind. Cannot borrow it as mutable. I didn't want it to borrow it as. Oh, because we are. So this needs to be iter mute. And map as mute. There we go. Okay. We have an error though. Oh, because this is mutable, this also needs to be iter mute as mute. Okay, cool. So we're actually mutating the whole structure there. Okay. I think I've now lost the capacity to explain what I'm doing because it's so late at night. Okay, we got further. We got down to 502 now. Okay, so y0 iteration 0 reference is none. That's a bummer. Because that should be populated. Why is it not? Can I go and see, look, what does that actually look like? What is y0? It should have a 0. Oh, it is a none. Oh, right, that has holes in it. Yeah, so we're looking at a component. The component actually is none. Yeah, okay, I misinterpreted my own, how my code was going to work. So this is a hole, so that will be none. So we should just assert that it's none. So assert that iteration 0 is none. And that's all we have to say. And then we can say the same thing about iteration 1 is none. It's no longer night on East Coast, it's morning. I know, I've been up too late. Would asref and then be correct? Is that what I ended up doing? Pretty close, except I turned it into mutable. So let's give Japfo a point. Yeah, I need to wrap this up and go to bed because my brain is like mush at this point. Yeah. The first two iterations are holes. The second two actually have value, which makes sense. Yeah, okay. So we finally got it working? Oh, thank God. Pass all our tests? Oh, wow. Look at that. I can go. My reward will be blessed sleep. It's not too late for you being productive. That's true. It just means that I'll sleep in longer, and if I stream tomorrow, it'll start later. Yeah. Okay, so let me explain for everyone who's really confused at this point. So let's start with a simpler example. Here's a simpler example. So this program that we're compiling and running on this bitstream, right? It says that the overall bitstream named foo, so that's a foo, interpret it as loop twice, read an unsigned integer, name it x, and give it 8 bits. Okay, so we have two 8-bit values, and we can name them both x because this is a new kind of variable that I'm making. So if we're in a loop, then any part that we parse goes into a vector, and every slot of the vector will be populated in order. So the first time through the loop, this is actually x sub 0. The next loop, it'll be x sub 1. It's actually only a coincidence that I also is the slot number. I could say like 10 to 12, and this will still work because it's counting from 0. It ignores the loop variable. So this will still work, right? But anyway, that point aside, this becomes a vector of 8-bit and integers. So the first one will get 12 hex, and the second one will get 34 hex. That's the simplest case. We have a vector with 2 elements, right? So the overall value for x is a vector with 2 values in it. But we can go into x's iterations, and we can see that there are 2 of them. Each iteration will be a component that will have its own value, the individual 12 and 34 hex, and they remember what their format was, and they remember where in the bit stream they started and how many bits long they are. So x0 remembers it starts at offset 0. x1 remembers that it's at offset 8. right? So the overall x has a vector value, and then each index is an individual unsigned integer that remembers where in the bit stream it was. Also, as a side effect, we wanted to make sure we can reference into x using an index. So that picks out the iteration of x that's the second iteration and picks out its value. So that's why we expect that to be 34 for foo, because the return assigns a value for the overall thing that we're in. All right, so everybody got that? So then the complicated case, if you understood the simple case, then the challenge is to understand this one. In this one, foo is much more complicated. We have an outer loop that runs twice, okay? Every outer loop we have an 8-bit x. So that means, same as in the simple case, x will be a vector with 2 slots in it, and there'll be a byte in each one. But we have, now here's where we get tricky. The first iteration, we have 4 inner loops. The second iteration, we have 6 inner loops. So we loop a different number of times based off of which outer iteration we're in, right? So let's say we're in the first time through, then we're going to loop 4 times. If we're on the second 2 of those 4, parse 4 more bits twice. So we skip the if the first time, we skip the if the second time. On the third time, we populate y slot 3, right? We skipped slots 1 and we skipped slots 0 and 1, and we're filling in slot index 2, or the third slot, right, with 4 bits. And then the fourth time through, we parse a y again, so we're going to the fourth slot of y, index 3, and putting another 4 bits there. Then we fall out of the outer loop, and we go loop the outer loop, fall out of the inner loop to loop the outer loop, and we get another x. And then we go into the else the second time, right? And then we have 6 loops. The first 4 times through, we parse 2 bits. Then we loop 2 more times doing nothing. So from the input of, I think it's the same input. No, with this input that's carefully crafted to match those slot numbers, right? The first time through is the first byte, that's x sub 0. And then after that, we get x or y02, y03, because y00 and y01 were skipped because we iterated the loop twice without populating y. And that's important because if I had like a UI, like UIZ of 1 bit, I'd want there to be as many y's as there are z's so that we can say, we can correlate the two, that the third time through the loop, we get y3 or y2 and z2, right? So z wouldn't have holes, but y would. Anyway, so there are 2 holes at y00, y01, and then y02 and y03 get the next 4 bits each, right? And then we fall out and we go to the x again, so that's this byte. And then we go into the bottom loop where 6 times, but only the first 4 times do we parse 2 bits each. Then we actually end up looping twice more without doing anything, so we're not consuming any bits. So we consume that many bits total, all of the bit stream basically, and then x should see 1 vector with 12 and 34 in it, right? And this is where it gets really crazy because the 12 and the 34 were in different parts of the bit stream. They had a byte separating them, but now they're slammed together as if they were adjacent. And then y looks really odd because it's got the hole in there, and it's got the first, the 2 nibbles from the second byte. Then we skip a byte and we have 4 groups of 2 bits each for the second time through. And then, one of the key jobs of the parser is that we should be able to go into any of these iterations and know exactly where it started and how long it was. So y02 starts at bit 8, y03 starts at bit 12, y10 starts at 24, and then 26, and then 28, and then 30. And they all each retain the bits that they parsed out, and they remember what format they are, and all that good stuff. So I hope that helped anyone who's watching who is sort of confused, but maybe we're not confused enough to be able to pick it up again. Hope that helps a little bit. I gotta go sleep, but I'm in a good state because all our tests are passing, and we have contextual vector parsing working. So what's next after this? What are we gonna do tomorrow? No to-dos about, how about comment-based to-dos? I have a bunch of those. Skipping the old code. We have, oh, this isn't valid anymore because we actually did fully add the component now, right? So that is invalid. All right, so there are a couple cases where I think we might need another error message printed. I don't think this is too gross anymore. It was worse before. So now when you ingest a component given a context and some arguments, you get a component and a return scope because the component might have given you an error, or it might have said that it's not an error and you can continue. So, you know what? I'm going to say it's not super gross anymore and we're fine. All right. I don't think it's possible to reach this code. So this is if we're unable to, okay, that's if the composite doesn't actually have a format. Yeah, I don't think that's possible. I think if we're ingesting context, oh, and someone pointed out before that context is redundant because this is a method of context. The difference between ingest component and ingesting context is that we, right, it's because we put the thing to ingest into the context. Whereas this one, we're making something new, right? Actually, that's not true either. I lied. Okay, or I didn't realize it. So this ingest component is actually a wrapper for ingesting context that finalizes the locals in the components and extracts the component out. So actually, I'm going to put a to-do here. Fix these names. Or fix this name. And I'll have another to-do for the next one too. Okay, because I can't do it right now because I'm super tired. I'm just reviewing what I'm going to do tomorrow. We have the error. So I have this note, consider differentiating between different kinds of errors or attaching useful information to them. Right now, we're actually not needing to do that. So I could just make error a unit type. I think the only reason I didn't was I wanted a placeholder in case I needed to pass information from one level to another. But because a lot of this is being done in a context class, when we do hit an error, what went wrong and why is actually captured in the context anyway. And the only reason I'm using result at all is to allow a short circuit. So might as well just keep it a unit. Yeah. I'm considering just like keeping that the way it is and just saying this is a placeholder for if we have any future need to pass information up that isn't captured in the context. If the function hit a trigger an error shouldn't, yeah, so that needs a test case to prove out. Okay, yeah, so we might have other starting points. Why might we have other starting points? Oh, if we need a concept of global variables. So this won't look up the composite structure at all. So we don't need to have other starting points if we're okay starting at the current composite, the composite that's in the context. But if we need to go up to higher levels, then we'll have to have some way to get to them, right? I guess that would be in the context, there'd be like a globals or something else. Can we do this in a better way? Exactly. This is a wart that comes from the fact that nil is allowed to be a value, but it's not a member of the enumerated type. Instead, I used option. So we have to unwrap the option when we're converting it to a string. So I will get back to that one. Oh, another thing we should do is hold on. Let me get through this first. Remember that turns an error with the dynasty into a return scope with the side effect of marking the component. Oh, I think that's because this is so common. Okay. Yeah, so what I want to do before I end the stream is all that ugly code that I wrote, not in the unit test, so we can close that, close this, close that. Token's okay, output's okay, grammar's okay, that's okay, build's fine. All right, so here's where we have really ugly code. That is ugly, so let's mark this as to do read needs refactoring. Okay, I'm gonna mark all the ugly places. This is all okay. Oh, here we go. Ugly code. Needs refactoring, right? I don't know if I need to mark it as needs refactoring because I can just scan later and I'm just looking for a horrible indentation. I mean, this is not so bad. So we're done with that one. Okay, expression. Yeah, this is fine. Except for this. Needs refactoring. Yeah, this stuff could probably be moved into the key value class or some such thing. Okay, iterator. That's not mine. Value. It's probably okay, right? Yeah, this is all good. All good. Okay. And a reference. I have a feeling we're gonna run to some monster code here. Oh yeah, look at that. Oh yeah. That's some badass indentation. Okay, so definitely needs refactoring. Okay. That is horrible. Okay. This one, well, this one just has a long comment because there was a problem with using the on error, so I had to go straight to the current statement span on error. Even then though, like this probably should be refactored out. Like this should be a function and that should be maybe. I'll maybe challenge myself later about maybe I don't need to refactor that. Okay, component. Yeah, that's ugly. Like that's practically unreadable to me. Okay, all this is good. All right, statement. It's always a bad sign when the horizontal scroll bar isn't all the way to the left. This is getting a little bit much. Yeah, maybe not terrible enough to mark. This is kind of pushing it. What's this, the for loop? Yeah, these are all okay. Yeah, getting a little rough here. Yeah, this is already consider refactoring there. Yeah, okay. These loops are kind of tricky because they're multi-step and lots of branches. Okay, in part, this is just a test. Okay, then we're done. Cool. So I think actually probably next step then, before, well, just to see if I'm missing anything, I should probably tomorrow try to parse this and actually try to try to parse a GIF file. It should work. We should get back the whole composite structure, right? So that might be the next thing I do. Make sure that we can actually parse with the Rust-based parser. And to do that, I need to make a main program wrapper for it that can read the bits from a file. Yeah, okay. Then do the refactoring, and then the next step after that is to start like making scripts, like a scripted host for the thing. And then after that, it's on to user interface land. So where to leave us tonight? How about we go back to vector and we just kind of gaze at this while I rate someone. So there we go. Leave you with that nice example there. No channels live. I think we just have to end the stream. There's no one streaming this late. Only I am crazy enough to stream this late. Okay, well, I gotta go because I gotta recharge my brain. How are we going to implement the UI? I think I'm going to use these things, WGPU and eGUI. That was the last project where I kind of got familiar with those libraries. So I kind of wanted to do a real UI with them. I was only doing a toy UI at the time. But the other alternative that a viewer mentioned was the slint. So I could try making a slint UI. Had no idea what that entails, but apparently it's a thing. Yeah, well, the eGUI shouldn't be too hard. I guess the parts that I'm worried about are like, I don't know if there's this tree view combination thing, and I think we'll have to roll our own hex editor. But like, I think there are like list views and there's like the basic widgets are in eGUI, right? So it probably isn't too terrible. Yep, so we'll leave you with that. Can always pick one up from there. Yeah, so in the past I've used full tick, and I got that idea from Are We GUI Yet? Going to pretty much just clone the Wireshark GUI. No, I just use that as an example. So like, probably what I'm going to do is have the hex editor front and center on the left. No, left center vertically hex editor, and then on the right we'll have like a breakdown as a tree. So because I kind of want to do left-right comparison. Click on something in the hex editor. On the right editor, it shows it in the tree. Click on the tree, it shows it in the hex editor. Kind of like side by side. That's what I'm thinking. Yeah, that's probably what I'm going to do. I just use this as a when someone asks like, what am I making? I can say, in a nutshell, I'm making my own version of something like that. Okay, well, no one to raid. It's always awkward when I'm not raiding someone because I usually hit this raid button and then I hit OK and then I chat for a while, but now I just have to hit the end button. Have a good night. Have a good rest of your day. I will see you later. Bye. Here we go. I'm hitting the stop button. I hate doing this. Bye bye. No.